looking for your video.
Oh, well, I'm on my phone right now, and so there's the little chat on the bottom. So it's the chat of this live stream. I don't know what else. Like Divergent Droid posted a couple of comments underneath it, so he found it. But you've already seen it, man. You've already seen it.
Yeah.
I'll repost it. I just went and grabbed it. I just reposted it there.
Oh, right. Yep. Good video. Yeah, this is the thing is that, like Travis has been describing a lot of these things for years and everyone's just been basically gaslighting him. And I would say that we are in pretty much agreement on what's going on. And it's funny how the people who have actually been out there and really gone out and looked, and as long as you go out there and you're not looking with a preconception of it already being a ball, then you can't help but come to the same conclusion. Right? And it's only if you actually go out there looking like, oh, I'm going to prove the globe. Oh, look, see, that thing disappeared once it got to the horizon. Boom, globe proven. End of story. Thanks for coming. Like, that's about as big a fallacy as you can possibly derive. You see something go over the horizon, if the Earth's a globe, you'll see something go over the horizon and disappear. It disappears. So, disappears over the horizon. So therefore Earth's a globe. That's just the biggest fallacy around. What else actually happened? What else could be the story? What else may have happened for that to happen? And I think that I've shown some pretty good evidence for what's actually going on.
Yeah, that like a planar perspective grid essentially accounts for the factors without any actual curve. And it's really interesting, being able to see it from both, 180 degrees from both ends. But is that, the way I worded that, is that like that a planar perspective grid is all that's needed? Because I know you'd mentioned that during the presentation, that there isn't really a need to bring in a curve, even though a curved effect could be interpreted by just maybe one or two parts of it. If somebody just takes one limited component, or even cherry picks one observation to say, oh look, that's connected to what a curve would be. But when you when you actually look at a wide range of the observations and looking in multiple scenarios and being able to identify the miraging and refractive effects, that really there is no place or requirement to insert a curve, because it's all happening within that planar grid of perspective.
Yeah, exactly. So like I showed, when we have like a really close horizon, our perspective can only go to that horizon. Your perspective can't go beyond the horizon. That's where we'll go into, obviously, and if there's mountains and stuff, then that's your perspective of everything above your eye level. As it gets further and further away, dropping down to your eye level, and due to the horizon being the furthest visual point that you can see the surface, if something now gets far enough away, it's perspectively still going to drop to a point where it appears to be on your horizon, even though it is maybe 20 or 30 miles behind the horizon. It's going to keep dropping down until it reaches the horizon point, because that's still a part of perspective, just as we see an airplane fly off and then reach that point there as well. And then it will just disappear from there. So all those things are still going on behind the horizon. We're still having that entire perspective happening behind the horizon. We just don't see that happening. We just see
I don't know. What should I think of the baller science, the globe flake science warriors? Like, I had a question. How do you feel about Paul's rephrasing that the horizon rises with the observer?
What do you mean by that?
well, as you rise up the horizon.
No, Paul. No. Were you here for the presentation, sir?
Yeah.
Okay, so you already know what Paul means by it because he said it over and over again, and I was listening. So are you trolling us right now, or were you not paying attention? Because it's one or the other.
Well, I think there was never disagreement that perspective is going to make things, rise up and go to the center of your vision, right?
Okay, so my question is, how do you feel about Paul's rephrasing what is typically said when, the horizon always rises to eye level? And Paul's saying, I think it's better to say it more nuanced this way. So what I hear is you agree with Paul. That's what I was asking. Thank you.
Yeah.
I don't know. I'm a little agitated still, but I'm glad some of it got opened up a little bit. I just think that Jeremy's chronology is wrong when he instigates stuff and then accuses me of being drama-based when he's clearly not following your rule of keeping interpersonal stuff out of it. So I'm stuck. He's totally accusing me of being drama-based when he totally instigates. Even starts it and continues it Well, you're relying upon him to mod. He got railed this morning. I hope you heard it. His only answer was to turn me down, not listen. So that's how the gatekeeping shit comes up. It's not fair, but that's how it comes up. If you're relying upon him to do his job, you have a communication problem with him.
The crickets are louder than you right now.
Yeah, and making better impact as well. I can't believe that in this whole group, nobody's saying anything. Zanick, are you listening?
I don't know where Zanick has been. He would have normally chimed in on a presentation like that, but he's been quiet all night.
He put in hours and hours yesterday, I think.
He's probably not there.
Yeah. Okay. Sorry. I don't mean
Oh,
to
I'm
interject.
here. I'm listening in the background, making sure
Yeah,
you guys
so-
don't get too far off the rails. Protecting my families. My
Zanick, I'm going to have to say you're the best. I just, as far as Glovers go, I just think you do it the best.
What about Jake? He's right there. He's my favorite Glover. And you're one of my favorite flat earthers for sure. I just have a picture. He dressed up in some spacesuit going into those old discarded space equipment garage sales and having a heyday. Do you have like one of those things that was on the Back to the Future? The thing that drove the Back to the Future Tesla, or
All right, just hold on, Zanick. Plane, were you going to show that?
Yeah, I just put something in the chat. Who was the guy that was talking about the horizon not rising a moment ago?
He's gone. He's gone.
Travis.
He's
Yeah,
gone.
I'd like to talk to Travis, but that would be hours and hours of interaction. I wasn't really into-
Appears to be below the horizon.
That's due to perspective. That's an angular
Exactly.
identity.
It's due to perspective. And on the opposite side of this horizon, it's also due to perspective. Now, if you want me to go into it, let me close this out. And I'll show you. See, now we see this boat here. So I showed this in my presentation as well, looking to be below the horizon. But then I show you on another day where you can see all the way down to the shore here. And you see a boat that's miles further than this, all the way to the hull with the horizon still behind it. It's in the presentation. Now, when we get over here, now, if you look in this area right here, this spot right here, you'll see lights appearing. Go back. Now, I don't think I can zoom here. No, I can't zoom that. But you can just see a little dot forming here and a little dot forming here. And there are these two dots here. It's really hard to see. I may even have where I've stabilized this footage.
Wait, go back to the boat that's hidden. You're saying that because that boat is beyond the horizon, we can't see it.
Okay,
Is that
so
what
this boat right now, and I can go into, oh, I can't right now because I've just changed.
You can walk me through it. I'm not going
Okay,
to.
Okay, so this boat here, a lot of people sit there and go like, oh, what are you trying to say? That the hull is actually down here? And then they put
Yeah.
a boat and you go, you see this hull? You're trying to say that's there like that? Yeah, that's
That's
exactly what I'm saying. Because prospectively, if you're on the opposite side of that horizon, you'll see that hull right here. And if I put a boat right here, we're going to see the same thing. The perspective of these two things are exactly the same. They're just on the opposite side of the horizon because the horizon is your dividing line. of
I
perspective.
totally agree. I think, Jake, do you agree as well? Jake's not paying attention anymore.
Okay,
Yeah,
so
I
the
can
horizon-
sperm out.
No,
Yeah,
I stepped away. Sorry.
Do you agree? I think he's putting this in interesting terms. This boat, we would say that the water is curving and that you're on the other side of this curve. And if the boat was closer to me, like it is to your friend on the other shore, it would be below the horizon. So we'd see the hull, and it would be the tops of the masts would not really line up, but they would be following the laws of perspective or geometry.
And what we would see is that, let's just say if I was to put this same boat in the same position here, we would have the boat sitting here and the sail would come up and this section of the sail, although this is an inferior mirage, so it's slightly different, but let's just...
Why do you
shits
say,
and giggles.
look at how it's angled. It doesn't look like it's cutting back at all. It has a distinct angle coming
Yeah,
outward
no.
from the tip. It's not coming back in. So
Yeah,
that boat
there's
is,
an inferior mirage there.
where? Show me the from mirage.
I did, but it's super tiny.
I know.
What
I
you
don't
don't
think
under-
it's
what
not
you don't
tiny. It's not
understand about-
large enough to hide the entire hull, which is.
Yeah.
So you're saying the hull is actually where that bottom of the sail is? There's a hole there. We're just can't see it.
No.
Well,
it's
that's what it has to
being
be because
swallowed up
things in your
below
angle,
the
things
inferior mirage. Right, it's being swallowed up below the inferior mirage.
the water is not
The
inferior
inferior
mirage.
mirage. The inferior mirage. No, the water here is not inferior mirage. No.
Even to the sail, right there. That's everything to the sail is not inferior mirage on the
No.
water.
Yeah, the inferior mirage is teeny tiny.
Starts there.
Very tiny. Yeah.
Okay, but where's the
When you
where's the hull?
have waves and stuff as well, it's much harder to spot the inferior mirage when you have waves.
I agree. I don't care how big the inferior mirage is. You should be able to tell me where it is, where the hull is hiding in the inferior mirage. Because I did some analysis to I think one of Travis's pictures, and we started comparing sails and the masts that had actually lookouts and things on them, and we started looking at the angular size of them for where they were with each frame of the picture that he produced, and it didn't add up for what you're saying. So you're just saying it. You got to look at if there is an inferior mirage, and you got to say what the angular size of the inferior mirage is. Where's the hull? Yes.
Remember this?
Yes.
And how this hull appears to be below the horizon?
That's due to perspective. That's an angular
Exactly.
identity.
It's due to perspective. And on the opposite side of this horizon, it's also due to perspective. Now, if you want me to go into it, let me close this out. And I'll show you. I really should go eat. I haven't eaten, but I'll keep going. Oh, no, wrong one. No.
It's like when I show you the picture of the, so back to the windmills, when there's 200 feet of this thing missing, and always seeing this thing down to the annulus on the water with one blade.
Good thing we're now establishing that occurs and has nothing to do with
Thanks for the interruption. I appreciate that. We're not saying that at all. He in his own way is actually talking about the curvature, although he's saying it's really something that's being absorbed into our line of sight via the mirage. And that's where his error starts and ends.
Okay, so let's describe this. How would you describe this? That as this boat moves further away from the horizon, we see it disappearing from the bottom up?
Yes.
So it's moving away from the horizon, right?
It's moving
as it moves further away from the horizon.
It's going away from the horizon, correct.
Okay, cool. And now as this one moves closer to the horizon, we see it rise up, correct?
Yes.
Agree with that wordage?
Yes.
Okay. Right. So, I mean, you can have a quick look at this as well. Where did I go there? Right. Okay, so what we're going to watch here is, this is what happens because it happens, both of these boats aren't moving. Okay. So as I drop myself from a high point to a low point, what we see is a teeter-totter, right? We see this teeter-totter. And as I go lower, that's bringing the horizon closer to the boat on the left, and it's moving the horizon closer to me as well, like for both of them. And as we move the horizon closer, what's going on is that boat behind there on the left-hand side is now going to appear to drop below. And as we move the horizon closer, the one in front is going to appear to rise. But if we get rid of that, what we're seeing is this. We're seeing this perfect mimicking, teeter-tottering of each thing. Now, what did we describe before? We described that as the boat
before you go any further, Paul, I agree with all you're saying, but the rate
Can you let him finish? You always come in at the absolute worst times. If you just flip and interrupt every time, can you just figure out how to not do that?
Well, sure. I thought it was an appropriate time to put a key point in, but go ahead. I'll wait to the end. Go ahead.
Oh, good. All right. So now what did we establish before? That as a boat moves closer to the horizon, and I'll escape out of here so you can see what I've done here. We have this sticking up just over the top of the horizon, and we have a boat here on the opposite side of the horizon sticking up over the horizon. As they both move closer to the horizon, what we are going to see is both of them appear to rise up above the horizon or onto the horizon. And now what else did we also establish? As a boat moves further away from the horizon, it will now appear to drop below the horizon. So as a boat moves further away from the horizon, it will now appear to drop below the horizon. Now, what we know is that on our side of the horizon, it's perspective, right? We know that. We can see it. We know it's not actually physically going below the horizon. It's all perspective. It's perspective on both sides. There's no difference between these two things. This is perspective on both sides, right? Now,
no, that's not right. But
I can show you this, right? Now, let's just skip through all of this. Okay, here's a picture that Travis took where this is the same boat. This is Travis the Plain Truth, Omni Copernicus. This is the same boat. Let me just I'll do this instead so I can point. So these two are the same boat. He had a friend on one side of the horizon and he's on the opposite shore. So he's on one shore and he's on the opposite shore. Now here we have an inferior mirage because why? This is in front of the inferior mirage is always going to happen behind the horizon because the inferior mirage will cause a new horizon. That's what the inferior mirage will do. It will create a horizon that is closer to you. Now this is how Travis saw it, and due to it being an inferior mirage, he's seeing it cut up here in the sails. Sorry. Now on this side, we are seeing the same thing, but because it's not in an inferior mirage, there's no inferior mirage here, so we're not seeing it cut up here in the sails. We're only seeing it cut here on the boat. So we see the horizon cutting right here, right? So that's what we're seeing. This is where the horizon is cutting across here. Now let's go to this. Now this is mine. Just happened. This is not any cutout. These are two boats that just happen to be in the same position, literally within probably very similar position from the horizon, distance away. And what we see is this boat here cutting across here in the horizon and the sail coming up here. And we see this one with the horizon cutting across here in the sail. If I just do this and I add a boat here, we're going to see this boat all of a sudden be right here on the horizon.
And that's not where they should be.
And
You
this
wonder
one's
why
going to
that's
be here
not.
like this.
That
Or
can't
maybe
be
this one would
possible.
be a little bit lower. Maybe it would be a little bit higher. But it's not going to. It's going to be in this kind of vicinity, and that's what it's going to look like from the opposite side, right?
I agree
Now,
that you see. Can I make a comment, or you want to keep on going? Because
no,
I
no,
like
make
to.
a comment by all means.
Pardon me? Want to keep on going? Okay.
No, make a comment. Do
Okay.
this in a second.
So going back to that picture, I mean, it seems logical, but you throw out perspective when you do that. They could be the same height. If they're the same height, those sails, the peaks of the sails, then that would be fairly appropriate. It'd be very close. But when you bring that boat closer to it and you line those sails up as where they should be, that's not correct due to perspective, because the farther away, if you're observing these two boats below the height of the top of the sails, then the farther away sail will be lower in your field of view than the foreground. It's easy to say that, oh, now they're going to be in line, but they're only in line if you are going to be observing these two sailboats at the same height as the top of the sail, which
Oh,
you
you're
are not.
saying like this.
That would be
You're saying
impossible.
this.
That wouldn't be possible.
Okay, yeah, but that's just a bit of
That's an
semantics and
important
stuff.
point. So I think it's
It's just
interesting
be slightly
because
higher, but either way, what we're doing is
slightly
we're showing
higher.
that these-
If it's twice
these
as
two
far
are-
away, hold on. If it's twice as far
Okay,
away,
it's gonna
it'll
be
be
low.
twice as low in your field of view.
Well, it could actually be even slightly lower. That's cool. I don't have a problem with that. But what I'm saying is that what we are actually seeing is that this boat here is in a similar position, right? So it's a similar
I think
position to this one. It could be
it
slightly
feels so.
lower, but I don't think it's too much lower, because if it was,
It'd have to be.
we would see way less of the sail, unless this is friggin' huge, and I don't think
Well, I
it
think they're
is.
two different boats, and
Because
this
this
must be a much larger sail
This
too.
is miraging from here.
And it's a
Now-
larger sail.
Now let's go to this. And what do we see? We're watching these boats move away from the horizon, and they're physically dropping below the horizon. See what's going on? They are moving away from the horizon, and they are both dropping below the horizon. Okay? Now, does that remind you of anything? If you were looking from the opposite side, how the sail drops below the horizon? Now, when we look here, and we just, on the right-hand side there, I've just covered it. We're imagining what we're doing is looking at it from the opposite side of the horizon, and we see the boat rise up. And as it comes back closer towards us, we're going to see it disappear from the bottom up. It has nothing to do with Earth curvature. It has everything to do with perspective. All right?
I don't know how you
Now,
say that, but
is-
okay.
But you
is this
acknowledge that
just-
it would be the same. It'd be the same for a person walking up and over a hill as well, and the person's videoing from the other side of the hill and seeming to be obstructed by the hill. It'd be
The
the
whole
same
point-
thing, right?
The
No,
whole
I don't
point,
care.
Paul,
That's
is that
fine.
it's the rate of change. It's the rate at which these things fall and rise. That's what we're disputing. It's not saying that it won't fall and rise. It's saying that, well, actually, it won't fall if it's flat. It would continue to rise up to eye level if it was at the same height of the observer.
Right? So without fail, 100% of the time, when something moves closer to the horizon, it rises. It appears
Yes.
to rise. And when something moves away from the horizon, as we're going to watch this move away from the horizon, it's going to get to a point right here where now it appears to be below the horizon, because it's now further away from the horizon. And as it goes towards
Because it's
the
closer to
horizon,
you by basic geometry. It's closer to you. Why does it go down after the horizon? I mean, we're saying the same things. We're making different conclusions, and I think it's admirable. You've done all these videos. They're
Why did it go
fantastic.
down?
But you've
It goes down
you've
because
drawn the wrong. Hold on. You've drawn the wrong conclusions, and I can say that confidently, because perspective doesn't work that way. As it gets farther away and hits that horizon and starts going down, why would it go down? If you're an observer on this piece of water that's supposed to be flat, anything that is below eye level will rise to eye level. Anything above eye level will go down to eye level and not go a micro angle below eye level as it gets farther away. There's no reason for it to do that.
Okay.
You haven't really thought of that, I think, maybe. I just think it's kind of crazy to me. I love the videos. You're taking fantastic stuff, but you're just drawing the wrong conclusions.
Okay. So here we go. This is where I got a friend of mine in this boat to go from my jetty to the opposite jetty. So I'm now currently standing on Brighton jetty, and I had a friend over on Grange jetty. And so what I have said to you and have put forward is that we have this visual ramp right here, and this is perspective. Over
Granted.
here is Grange jetty. Now, unfortunately, I wanted him to just go straight, but I forgot about the fact that I have this privilege of knowing that that's exactly where Grange jetty was. His GPS told him to go all the way out here and then cut back down again. So it was a little bit difficult for my friend to find him straight away. Now, what happens is we watch him go up a perspective grid until he hits the horizon. And I deliberately wanted a miraged horizon because that way I knew that there would be a horizon between us. So this horizon on this day was at approximately 3 miles away for both of us. So there's 2 miles of inferior miraging. There's 2 miles of mirage area. So now this has reached my horizon. He should have been able to see it over here right now, but he didn't know where the boat was. He's looking around. He was actually getting quite frustrated because he couldn't find it. So he was kind of getting a bit annoyed. And I'm like, dude, you got to pan to your right. And he's like, am I right? You're right. And I'm like, no, you're right, bro. Pan to your right. So he's like panning to his right. He's looking. And then you see all this area down here, which we were looking at before. Okay, he couldn't see it. I think actually it was just there a second ago. He couldn't see it. We see I'm over here on Brighton jetty. See this visual ramp that he has right here now? And my visual ramp right here? Okay. So he pans across and boom, there it is. He sees the boat now and I'm like, yeah, you got it. Right? So it's in the mirage here now. Now what we're going to do is we're going to watch it come down this ramp for him and disappear for me. So it's going further into the mirage, and it's still in the mirage there for him. And now as it keeps going further, and it's about to break out of his mirage, about there somewhere, right? So we see the horizon there, so it's about just broken out of the mirage now, and it's about to come down for him, okay? And I'm still having it miraged here. I can still see it. And now as it starts to drop on his side, I'm starting to lose it. This is perspective. He's dropping here in perspective. Nothing to do with the curvature of the Earth.
No, the rate at which it drops is what we're talking about, Paul.
Right.
You have to acknowledge that, right?
Then-
They both would drop in
then
both
what's going on
scenarios.
here?
It drops more on the curved Earth, right? We have to agree to that at least.
No, I wouldn't probably agree to that.
Well, then we have
no, I don't know.
we're done. I guess we're done at that. That's really obvious to everybody, but maybe
so-
you.
Right here, right, well, let's go. Right there is pretty much where I start to lose it, where his roof is still just slightly visible, but it's gone for me now. So then he keeps going. Oh, let's get to about here. And this is where the water line is here now, and the boat's all the way down here below it. I can't see it. And now from this point of view here, we see the jetty right there. We see Brighton Jetty right there. Then he just turns around. Oh, and we do it from the opposite way. Now, either this week or whenever the conditions are right again, we're going to go do this from the 12.6 mile observation, and I want to try and do it when there is no mirage in the way. So that way we can still have a horizon being at 12.6 miles, but we're going to do it on a day when it gets warm enough so there is no mirage. And now here we see it's in vision for me, and as it starts to come back down again, which is here, it's starting to come back down again now, he starts to lose it. Sorry that he had it blurry. I told him how to get rid of the blur, but he couldn't work it out. And then now the boat starts to come back down towards me.
Who's paying for the gas for this little excursion?
I
Hey,
did.
get your boat and take it out 12 miles and then come back. You're 24 miles in their boat just so I
Oh,
can
yeah,
go.
it's not cheap. You know, I mean, I had to give my mate a few $100s for this.
I know.
You know,
That's a lot of
I've done
work.
all of this-
Great
Oh,
video, by the way. Good job.
I've spent a lot of money doing this over time.
I
Never
think
received $1 for it. So,
I-
and I'm not
yeah.
asking for $1 for it.
I know these are what our inquiring minds
Right.
wanted. They want to know.
Yeah.
They want to know the truth. And you're doing a lot of
Yeah.
good experience. But why do you think it goes over the horizon? Why do you think there is a horizon? Why doesn't it continue to go straight out into the distance? Why does it have to drop? Your perspective argument doesn't quite work because the only disagreement we are having is a conclusion that we're making by what we're seeing. The perspective works. The only difference between perspective where things are ramping up and then ramping away is the fact that the rate at which it ramps is the only difference. And why it goes down though is a big difference too. Why does it go down after it's past the horizon? Why is there a horizon?
The horizon is the dividing line of perspective. So here we have
That's not true.
this here is this, right? So
What is the dividing line of perspective? I know you're
So
saying
this
here.
boat here is this boat here, which is what she's seeing. She can just see the top of this boat here. He can just see the top of the boat here. They're both going to watch it go up, just as you saw in the video I just showed you. And as that happens, they're going to watch these boats also come up. So that's
But
what
that's
they're
not
seeing.
that's not reality for perspective. Perspective doesn't
I just showed you
clearly
reality.
states. No, I know you showed it, but that was
I just
because
showed it
this
to
is
you. Yeah,
That-
but
that's
see,
not
this
how
is the thing, though, Zanick, is what I'm showing you is
If I was
something
gonna
that has
fire a
never
laser-
been. Wait up, Zanick, let me speak for a second. What I'm
course.
showing you is something that has never been described before, ever. No
No,
one's
you're
ever
right.
described this before. So you're going to need time to soak this in, and many people are going to need time to soak this in.
I've been
I started
slow-
showing this a year ago, but now I've actually gathered so much more evidence for it that I'm showing this evidence now.
Well, I think
And
sometimes
I'm not.
Zanick, chill, dude.
Yeah.
we need to pause. I was going to make a comment.
So we watch it go up, it hits the horizon, and we watch it come back down. Now, this is what they're actually watching from their perspective sides. So they are both looking at this image on the right. For both of them, so we can see that that's the back of the boat. As that boat moves away from them, they are both watching the same thing. They are both going to watch the back of the boat climb up, and the boat in the distance on the horizon also climb up. We know that they're both watching perspective, right? So they're both seeing the exact same thing from either side of the horizon. It's no different. Once it hits the horizon, it gets there. Remember we established that when something moves towards the horizon, it rises up. And then when it moves away from the horizon, it drops. We established this. We established that that's what happens. We went over
But there's
that.
no
We
there's
went
no
over that
reason.
right here. I just showed you the reason. You just don't
No, there's no
understand it.
reason because we know due to perspective, due to simple geometry, if I have something that is at eye level, it will go farther away and will never change my center. It'll try to move a different up or down, but it will always stay at my center field of view for indefinite distances. It will not go over a hump. It will not go up, and then it will ramp out angularly because that's how perspective works. But it will always stay at eye level. Something at eye level, 100 feet away, versus something at eye level at 5 feet away is the same angular position. If it's at my feet when it starts out, this is what you're talking about. This is also perspective. So both can be true. Something at eye level, out to infinity, stays at eye level. You can't accept that. That's okay. We're going to get to
It's
the bottom
actually
of
that
it.
way around.
Hold on.
Can I
Okay,
ask you a question,
yes.
Zanick?
Wait, let me finish the last part of my statement. I was quiet. So something at your feet that is below eye level will, as it goes farther away, will rise to eye level. And the rate at which it rises will depend on what the surface shape is, round or flat. Now, if it's round, it will go to a distance, a apex, and then start going down like you're clearly showing. You're showing more rounder truth than you know. But
Well,
if
for
it
you,
isn't, hold on. If
rounder-
it, hold on. If it
Okay,
isn't round, then it will continue to go off in distance until it is up at eye level. It'll never get there, but it will try because it's always below eye level because we saw it at our feet when it left. But it never will get there due to perspective, but it'll always go up. It will never go down like you have misassumed here. And I hate to say you spend a lot of time on this, but I think you
Hey, land your
actually,
plane, dude.
well, I want to give him credit for doing all this. And I think
You've done it 12 times. Just like
I think
make
it
the
will come
points
to
go
a
back and
different
forth.
conclusion once you understand that.
Okay, we don't need you to say that in a
Talks
different way
for
every
an
time.
hour. I can't say 30 seconds.
Because all you're
Yeah,
saying
Yeah,
is
no,
like,
I'd
I
like
think,
people to be fair and each person speaking the length of time. Don't be
Okay.
unfair.
Zanick, I was wondering, this seems like kind of the crux of the issue to me. Can something be obstructed by the Earth before it reaches the horizon?
No, the horizon is that is the Earth, and it's what's going to obstruct it.
Okay, so what if we're seeing bottom-up obstruction like way before it even reaches the horizon? What's going on?
That can be caused by miraging as well. You
Okay.
still have things obstructed by mirages.
Well, I think we made a lot of progress. What do you think? Plain reality?
well, I
See
don't know.
what
I think
comes up?
plain reality is making a different point, which is like what Zanick keeps responding to is like, no, based on my understanding of perspective and the geometry that I use for it, then we know this will always happen. That can't take place, even when he's showing him videos of something other than what he's describing taking place in reality.
Exactly. And what I'm introducing, again, it's so new. Like it's never really been shown before. And humbly, let me be saying this as humbly as I possibly can, is that this has never been shown before. This is the
Can you
first time.
summarize what you're showing? Like
Okay.
summarizing?
Yeah, well, summarizing, basically what I'm saying is that the horizon is the dividing line of perspective. All right, the horizon divides perspective. So
I don't agree with that. I think if you had a
Zanick.
Let him
goal,
finish. I think he was still talking. Were you done playing?
no. So the horizon is the dividing line of perspective. So this is what I say the horizon is. The horizon is the furthest visual point where you can see the surface. Not controversial. It is the
Right.
furthest visual boundary where the sky appears to meet the ground or water. Also not controversial. It's all visual, and all visual paths converge to a vanishing point. But the difference is that what it is that it's where perspective convergence ends and perspective divergence begins. So once we hit the horizon, we also have perspective going on the opposite side, but it's just divergence. It's the exact same thing. There's no difference between the two, except for the fact that when we're watching something go further beyond the horizon, it's going to get smaller. And when something's in front of the horizon, it's larger. That's the only difference. But when it passes the horizon, perspectively, we are going to watch them drop. Is that
So he's
enough summary?
saying that like if you look at railroad tracks, right, they're going to converge into the distance. Now imagine those railroad tracks just representing our perspective. It's converging, and then it gets to the horizon. Once you get past the horizon, they would begin to diverge out, and that
Yeah, don't make
horizon
these
would be
symbols.
dividing. That horizon would be the dividing line of perspective between the convergence to the divergence.
Well, here's the
Yeah,
real,
hold on. Let me jump in to say I have this image real quick. Have you seen this plane? Have you seen this image? It just shows a perspective matrix. You've probably seen something like this. It's not necessarily incredibly fancy or anything, but if you want to just check it real quick, I put it in the live stream text. It just shows the convergence and divergent, like you're referring to.
Oh, right. Sorry. I was already right there. Yeah, exactly like that.
Yeah.
So we have convergence going up and then just divergence going back down again. That physically happens. That's how we physically see the world.
I have one. These are old ones that I have. I've had them in the folder forever because we used to. But anyways, this one's kind of an animated version. But yeah, it just reminded me of what you were talking about. But yeah, dude, this is awesome to think about it this way in terms of seeing it. It's like a mirror, seeing it from both sides.
Mhm.
It's really interesting. It opens up a lot of new considerations in my mind of like ways this could be tested. Because of course, people are going to want to know how is this exclusive between being over a planar surface with a planar grid of perspective versus what the globe would curve. What the globe would claim is a curve, and everything that would be involved with that. Because there is some overlap. Like if you had a hump of water, some of these things would overlap, but there certainly are differences, and that's what would be interesting to think more about. Tests that can be done in ways that can be done to isolate and show which one's exclusive.
Okay, now I think it's exclusive because perspective personally is always drawn over a flat surface. It's always predicted over a flat surface. We have Sky Free, who has done all their observations over a floor, flat surface, over just a few hundred feet of a lake, a flat surface. I said earlier how I'm actually building a 10-meter long perspective grid. That's 40 centimeters by 40 centimeters square, and that's separated by 20 centimeters for each section. And I'm building that 10 meters long, and I'm going to put like a little perspex pool all the way along it to create a water environment. And then I'm just going to run a camera and put things at different sections of that. Just run a camera for hours of the day, put temperature gauges there, put boiling water in there to warm up the water, put ice in there to cool it down, and then just watch the refractive effects happen and watch what happens over the day. And that little experiment that I'm going to do there, that's going to cost me about $2,500 to do that. Shit ain't cheap. But I think I'm going to get some really cool things, and we're going to watch stuff disappear at less than 10 meters away. And if anyone wants to tell me that the water from that point 10 meters away to the point 10 meters closer is curving at some kind of drastic rate to make those things disappear, well, I've got some land on the moon to sell you. It's ridiculous.
That's what they will say, probably. But so, you know, what's so fascinating about hearing the back and forth here is like he's showing you the video of it happening, and then when he goes and describes what's happening, you say that can't be happening because we know how it works. Here's the geometry, and basically what you're saying is just that it's like one way, and it just goes infinitely, right?
Yeah. So math works, you know, in mysterious ways. This is obvious to me. It's not obvious to Paul, and I respect Paul for all the work. He's not a dummy. He's a smart guy. But the problem here is this idea has a critical flaw, and the critical flaw is due to one of the fundamental laws of perspective. And that fundamental law I already pointed out.
You said it 12 times, bro. You said
I know the things but he's saying that that's not true. At the horizon, all bets are off. We have a convergent perspective, and then we have a divergent. And this is his own conjuring. He's come up with it himself. No one else has done this, and he's right. He's the only one. And I commend him for thinking hard about this. But let me ask you this, Paul: wouldn't it also be true, this divergent perspective? Wouldn't that also occur if the Earth was round? Would we see some of the same things? We could be misinterpreting it as round, and you could be right because it's how perspective works. Or if the Earth is round, wouldn't we see the same thing?
Are we going to see things disappear beyond the horizon? Yeah, of course.
Okay, so we're both saying we both love these videos, and we both know that this is going to happen. Your cause and effect relationship description is going to be different than mine, and you think it's due to this perspective law that's been overlooked for centuries. But this is actually what's happening, and I think the video I can't say enough, it's fabulous, unbelievable stuff. I love the video, and I love all the different slide up and back animation. That's fantastic too. But I just think there's a flaw in it because I think there's no reason in my mind to think that the geometry has an exception because you've replaced it with something different. That shows that there's a divergent perspective after a convergent perspective.
Cool. So let's just say for a moment that what I've done is now offered a full working description of how this works on a flat Earth. Okay. Now, you can still say that, oh, well, it would be the same on a globe Earth, but I'm now describing and showing to you and to everyone how it works on a flat Earth. So for people to then turn around and go, show us how it will work on a flat Earth, I just showed you.
You know,
right? Because when I go to these other images again, right? And like there's a whole bunch of stuff that you didn't see within the presentation. And again, what I would say is, take the time to go back and have a look, watch it.
I'll watch it.
I am by far nowhere near the smartest person on the earth and nowhere near the smartest person in this room. But I'm not retarded. And what I've gone and done is shown a whole bunch of things that have never been seen before. Now, when we look again between this image and this image, what I'm showing you with this image is that when we have a day that is a virtual, for all intents and purposes, a perfectly flat looking ocean, that's when I see all the way to the shore and can do a mirror test from the actual ground, from the sand. So it's interesting how every single time we have this perfectly, well, not perfectly, I can't use those words, every time we have this visually flat surface of water, then we see the furthest we can possibly see. And what happens is every time I go out there, just for something fun to do, and in general, I don't talk to people when I'm doing my filming and stuff. I don't talk to them about flat Earth. There's a few that I have. But whenever it's flat like this, I always comment to people, wow, it's really flat out there today, isn't it? And they're like, yeah, it's like dead flat out there. So on the days where it's flat, we get this, unless it's an infrared mirage, and then the infrared mirage will still be hiding stuff.
And you're saying that because this happens, obviously the horizon is now out by the base of that shore or the what do you call that, structure.
I think you should keep listening.
We're going back and forth. There's nothing wrong with what we're talking about with it. He has described something that is flat, and we would tend to agree with him.
Wait, what happens is so much of what he says gets lost, right? Like, for example, he just pointed out, like, he finds it interesting that when we have these favorable conditions and we look out and the water's super flat, that's when we see the furthest. You just skipped right over that. You just skipped right over that.
I actually said the horizon has now moved all the way to the shore, to the structure. So I actually acknowledge that. So I was going to say, so if you didn't cut me off, I was going to finish my one sentence. It wasn't going to be very long. In that we now are in agreement that when that water is flat, it is flat. The horizon has risen up. It's farther away. You see farther. And this effect that he's talking about, this divergent perspective, happens after it, which we can't see. But what I'm saying is that is caused, and he might even say it's caused also, and we both could be agreeing that this is caused by refraction. Not due to the Earth.
Right, just a second. So this is where your paradigm will then say that when it's clearer outside and the water appears flatter outside, and we thus see further outside, that's when there's the most refraction occurring, creating that illusion that it's super flat and that we can see further.
No.
That is the required position
No,
on
because
your side.
not at all. And so I'll retort with this one quick sentence. No, there are some days where we have it flat, and then it looks flat as like I'm a big water skier, so when I see flat, I get pretty excited when it's flat and there's no waves, and some oceans get like that too. In some parts of the world, crazy exciting when I see flat. I just love that calm look. And you can see farther sometimes, but sometimes it can be flat, and you can't. So they both can be
Deflection.
true.
Deflection.
Deflection.
I'll just repeat it.
Sometimes it's flat, but
Deflection.
sometimes it's flat. We cannot see farther. I'll give you a picture of
Deflection.
one of those.
Red herring,
It's not
bro.
deflection, not a red herring. There's sometimes
Dude,
complete contrast.
Calm down.
Complete contrast. What you said, Witsit. There are some days where it's totally flat, and
You're
ships
gonna
and
keep
buildings
repeating it?
are you're talk through me. I'm just gonna
No,
finish
you
my
stopped talking, and as soon as I went to respond, you didn't like I was pointing out it was a deflection. So you want to talk some more and say it again.
because it's not
It's
a
a red
deflection.
herring. Well, I'm about to explain why. As a red herring, for you to say, sure, sometimes it happens, but sometimes it doesn't address what I'm saying, though. We're talking about the times that we do. We're talking about the times that we do see further. Okay, so in the situation that it's very calm, clear, flat, and we see further, in your paradigm, you're going to have to now claim that there is more refractive effects causing it to appear that way.
Correct. It's not a
Okay,
red herring
thank you.
because in direct contrast to that statement, there are plenty of days where it seems just as clear and calm, where you can't see farther. You see less far. So which is actually more representative of the reality of the geometry of the Earth? Well, you have to test for that. That's all I have
Well,
to
what
say.
we would do is we would look at the days that we don't see further, and we're going to start to see effects of inferior miraging. We're going to actually see the obvious refractive effects on the days that we aren't seeing further. That's a problem for your claim, though, because you're claiming that's when there's the least amount of refraction
No,
and the most Yes,
that's
and this is what I this
mostly
is the
not
same
true.
experience that I had. This guy's observations below anything I did out of the water. I had the same basic observation and experience though. When I would pull the camera out anytime we were near water, sometimes it'd be clear, sometimes it wouldn't, et cetera, et cetera. It's very simple. When it's clear outside and everything is calmer, you can see much further.
It's not
And for
true.
me to believe the Earth's a globe, no, generally speaking, it is true.
It's
And
not
for
true.
me to believe the Earth's a globe, I have to look at these observations when I'm seeing way further, and it's way calmer, way flatter, way clearer, and then believe that's when there's the most refraction.
Yeah, I have an example too that I posted where I can see it's much clearer and you can see a whole nother building that earlier in the day that was foggy was completely gone.
Look,
You mean to tag you on that? I wish somebody would put on the big screen.
I just posted a calm day down in Santa Barbara during the oil rigs. It was a very calm day, and
Maybe
that
was
was
trying to say something.
very clear.
Yeah.
Okay. Anyway,
Yeah, I think you already told us about that one.
this one I have not shown this one. I haven't shown this one.
So when you were saying how a building just appeared all of a sudden, look at the difference between here. So we got about 70 feet missing, and then we blink test it, and then boom, there it all is.
That's
That
cool.
same-
Did you see the thing I tagged you in?
Can you describe this?
Can you maybe just send it to me?
Okay.
So
Anyway, go ahead.
same camera height, same location, same distance,
Yep. Same focal length.
same day.
No, different days.
Oh, okay. The date's on the left. I see. Okay.
Yeah. So one was the 11th of October, which would be this one, I would say, and then this one here would be the 24th of September.
Right now, can't we all just intuitively tell that one right there is just the clearest, more accurate depiction of what is there? Right? Like, am I tripping?
Dead calm in the ocean. I just posted it. Dead calm. And you can see that both are dead calm. Unbelievable. You get a few of these days in Santa Barbara. One was on a very hot day. You see it's kind of smoggy because there was fires going on that day where it was loomed up tremendously. And the other day, it was calm with blue skies. Both are very calm. Which one is more representative of the geometry of the Earth?
I don't know. We just had.
Mirage.
No, they're both. Which one?
They look the same
One on the right.
elevation, just the water
The
looks
one on the right
higher.
has no miraging, actually.
No, the one on
Well,
the
that
left
one's
has-
I post that one a lot because it's useful for various things. I don't know that I agree that atmospheric magnification is like the entire kind of answer of what it is, which is what somebody put that on there. But nonetheless, like that actually shows what he's been showing all night. How when you have the horizon point that in this case is like closer, the object that looks like it's because of the convergence and divergence that it's dropping due to that effect because it's beyond the horizon.
Okay. Well, actually, mathematically, it should be higher in the distance than it actually is, so it has some looming, but it is lower, it is calm, and we are not seeing farther. So, contrary to what Witsit said, sometimes, and a lot of times, depending on the conditions atmospherically, we will not see farther when it's very calm.
Yeah, this perfectly proves what we said, which is where you're going to have inferior miraging.
See this right here, Zach?
At the end of the
There's a line straight across here.
Yeah, I've actually been
All
out there on a
that
boat, and that's
stuff all that stuff underneath there is an inferior mirage in this observation. And what I showed about this observation earlier, right? Because this is the one that I went over because you posted this to me a long time ago, and I have been over it a few times, but I need to, reiterate this: that when we see something like this, is a representation of what we're just watching, or what we're looking at. Let me do this. Like this, right? So this is the same thing. The buoy's on the horizon. That should start skipping now. So we have the buoy on the horizon, and when the horizon is close to us, so the buoy is representing the oil rig at the front, and the tower at the back is representing the oil rig at the back. And perspectively, what we are seeing is only to the horizon. our perspective can only go to the horizon, to the buoy on that day, and now it's further away. Things don't just magically raise up and down. This is all an optical effect. On the day when we all of a sudden see further, like I showed to you before, which was this picture here, right? Where was that? Was that just here? Okay, so here again, let me just move this back to here. What we are seeing is perspective. And I explained to you before how that little yellow buoy, how it seems to be high up on the horizon there. And then when we drop and we see further, that little yellow buoy now appears to drop. It's not actually dropping. That's just how perspective works. People haven't understood how perspective and the horizon works together to give us the world we see.
Well, I think the picture addresses your points as well, and it shows your points in there. There's several things happening in this picture. Can you see it at 29 after the hour?
Okay, hold on. Just have to...
So we have some. There's a good picture because it has inferior miraging.
Is that this one? The one that you showed earlier?
No, I don't think I've shown this one. And maybe it was part of a duo, but this is just by itself now. Calm day. I got it.
The one that was in the inferior miraging?
Yeah, there's some inferior miraging. You can see the C shape, backward C shape, or the actually C shape on the right platform, and then of course the entire platform for habitat is gone. Half of it's gone, and there's a bird actually flying along the water as well. This if you're saying that there is an inferior mirage that's hiding everything below the cranes and the platform underneath Hill House, I would agree that is not. It's a reflection, an internal reflection and mirage, as they call it. But the water itself is what we're seeing. It could be even hiding some of the water, but only a very small angle, because everything above that inferior mirage is not fake or generated or illusion. It actually is reality. So the water beneath it, and there's a band in between, the ether band, as Travis calls it. But the point here is not so much what you see, it's not how much is hidden, although it kind of is. It's really about its angular position in your field of view. Does that match the flat Earth or round Earth? And you're saying it has to be dropping because you've already given this new law of perspective, this divergence that happens after the horizon.
Yes. And that happens wherever horizon is created. So it's the horizon itself that does that. That's why I say it's the dividing line of perspective. I don't go, well, it only happens when there's refraction here or refraction there. It doesn't matter. No, it's the horizon itself. The horizon is the dividing line of perspective. So even within your image of what you've just shown here, right? And I'll blow it up, and I don't know if people are looking at my screen or whatever. But so we have this inferior mirage. We know that this causes upward refraction of light. 100%, we know that. And that's why this image now seems so low. But we still see a visual ramp coming up to the point which is the highest visual point, which is where the horizon is. And the inferior mirage is now creating the horizon here at a much closer point to us. And now everything starts to drop below there. It's exactly what I've been saying. I
know you're saying that, but like I said, all your videos are great, and what you are describing happens. It's just the reason for which it happens, I completely reject. And I reject it for the reasons I stated. I don't need to go into them anymore. I think if you think about it and start talking about perspective and where things are mathematically in your field of view, you'll find that there's a key flaw in your analysis. But that's just my opinion.
I have a question. How did y'all come up with the geometric horizon?
Is that
Zanick? Yeah, that was a hiccup.
I had one right then too.
How did y'all come up with the geometric horizon?
It's backwards engineered, knowing the known measurements of the Earth. So that's
Zanick?
The tautology.
Zanick?
No, we look at where things are in distance for known heights and see where they are based on distances away from them, just by taking the distance above the surface divided by the distance away from it, taking the inverse tangent and getting an angle. When that angle doesn't comport with geometry, that reality, then we say it's due to something else. We call it Earth curve. Yeah.
How did y'all figure out the distance to the geometric horizon?
By doing these kind of measurements. One of the first ones was the one down in Cyrene in the Middle East, but that was done a long time ago by Aristophanes. But we've done it. There's many other ways we've actually come up with that.
By doing observations?
By doing observations.
To the apparent
by mathematically deriving. Yeah, I think they just mathematically derived it.
Well, math is a useful tool. We use it sometimes to actually determine things.
But which one is it though?
It's both.
Is it both?
Yep, they reverse engineered, and they do the apparent horizon.
Wait, how do they actually get the geometric horizon?
The funny thing you could do.
Sorry, you go ahead. They're talking to you. Go ahead.
Well, no, it's okay. I mean, I've been dominating. We've been part of the main conversation. Everyone should jump in if they want to. But I want to make a quick comment. The way you can test for this, and I've said it a billion times, differential measurements. Anything you see, start, if you know the distance to it, and you can change the height at which you observe it, take 10 or 15 measurements at different heights above the surface without getting closer to it, and then see if that object comports with a curved surface or a flat surface. That's an easy way to do it, but no one really has done that yet. You've done one of the few things I haven't seen people do. That what I've talked about for years now, no one's done. So that's one way you can have to check. Take differential measurements. Take a measurement to oil rigs, go up to a floor, take another measurement to the angle to the object, go up a floor, repeat that 10 or 15 times up to a 15-story building. You could do it like in Santa Monica. There's lots of 15-story buildings down there, and then see what the object actually, where it is in your field of view, comports with a flat or a round Earth. You'll see that the refraction value could be predicted at any height based on those measurements. But no one's going to do that because it takes a lot of work to do it.
No, man, you've never done that.
I told you I haven't done it. I've done things that resemble it in single measurements, like I've taken up at Mount Baldy and down to the Huntington Pier, measured the angle. It's half a degree off where it should be.
The side that needs to do that is the one that's claiming to know that that's what's going on. And whenever people are claiming to know that when we make observations that don't comport with the globe whatsoever, and they claim that it's atmospheric refraction, they should be able to give a repeatable, testable claim for that. They should be able to go out and provide specific predictions for that. This doesn't occur, though.
The mountains are a great example of it also. Since you fly and you're going toward Yosemite, you can see Half Dome in the distance. You can see it's a 10,000 feet or a 9,000 foot peak. If you are at 9,000 feet and it looks like it's above you, you think you're, or below you, you think you're going to be able to clear it. And as you approach it, it suddenly magically rises, even though you're flying theoretically at the same level it is, same elevation it is. It's burned many pilots in the past that fly and think they've got this mountain range cleared, and as you get closer, due to the Earth curve, they don't. So that's one example that people that in reality can experience to know that they've mistaken the shape of the Earth.
So how did they come up with the geometric horizon again?
By knowing the actual diameter or the circumference of the Earth.
So not from observations.
From observation, yes.
So from observation to the horizon, or from the mathematical construct?
No, they made observations to determine the diameter and the circumference of the Earth, therefore the diameter, but the circumference of the Earth. Therefore, you know what the curvature rate would be, because it's a simple mathematical laws for dimensions of a circle. And then by knowing those angles, you can then predict where an object will be in the distance in your field of view. Pretty simple. That was just these are things that were done thousands of years ago.
Okay.
So the geometric horizon wasn't actually done by looking to see where it was. It was just mathematically derived.
No, it was looking to see. Just
no,
like
they looked to see the circumference.
They looked and they saw the rate of change.
Figured out how far away that thing.
Well, the shadows. When they had shadow where a stick near the equator did not have a shadow at noon, and then they walked 500 miles, stepped it off, and figured out that the Earth had this angular representation to distance.
Can we get that original paperwork, that original study?
It doesn't matter. It can be replicated. You can replicate it. A fifth grade class can replicate it. It's just something that anybody can do. The
geometric horizon was mathematically derived. That's all.
By the observation
from the circumference of the Earth.
Can be observation.
And Al-Biruni did it a different way.
Not for the geometric horizon.
Al-Biruni measured the horizon. Al-Biruni measured the horizon dip from the top of a mountain and came to almost the same number.
Tell me again, bro.
Within a third of a percent of what
Al-Biruni used the R value?
He measured the dip of the horizon, was able to calculate the radius, yes.
Right.
Oh, he came up with the R value.
He validated the R value is what he did.
So he didn't have to worry about atmospheric refraction. It's
such a small percentage of the actual measurement. When you're measuring up a hill or down a hill, your angle of incidence or that acute angle, because you're seeing most of the refraction when you're on the surface of something looking across it. The more acute that angle becomes, the more refraction there is. We all will agree that looking straight down through the atmosphere, there will be no refraction. Anything in between will just make it greater as you get to the. If you look straight down.
Tell the black swan that. Tell the people that observe the black swan that.
No, Zanick just said if you're looking straight down, you don't have to worry about refraction.
I think he means like looking.
That's not true.
Looking like a drone looking down at the ground, straight down.
You look straight down?
No, I'm saying if you wanted to really test
so just a totally irrelevant comment.
So now it's just objection from incredulity. Okay, got it.
No, it's called
nobody's actually doing that.
So I asked about Al-Biruni and atmospheric refraction, and your response was, no one would deny that when you're looking straight down, there's no refraction.
Well, you're not.
How does it have anything to do with?
I'll tell you if you listen.
No, it's that your comment wasn't relevant.
It is
to
relevant.
What was being discussed.
I'll tell you. Just let me finish and I'll tell you. So we all know that looking straight down, there's no refraction. Looking along the surface is the greatest refraction. So it's logical that as we go higher and follow the optimal curve path to be above the object would be the best scenario. It would be difficult to do without a helicopter or something. But you can do things just like go up in elevation. As you go up in elevation, the refractive value will be less. Less refraction effect will be less because that angle is less acute. Angle of incidence is the most critical element of refraction. So by doing that, you will have. So if you look up a mountain and down a mountain, you can do things like reciprocal zenith angles and figure out what the actual excess is. And they find that every time they do it. You can do it yourself. Go to Squaw Valley or go to whatever ski mountain near you. Look up a mountain. Have someone up there. Look down. Measure the angle to each other and see if the angles add up to 180. They won't.
No, listen, bro. If you both have sinking refraction atmospheric conditions to cause that, that could be one cause of it not matching up to 180.
But when you're
this is so irrelevant that it's off topic.
So plain reality claims that perspective is just looking like a globe because bottom-up obstruction looks like a hump in the middle. So he just claims that it's just like how perspective works, which means light has to curve upwards. There's no physical explanation for an everyday situation. The globe says light sometimes bends downwards, aka we see too far, where there's a clear physical explanation for it.
No, you guys claim it bends downwards always.
They do. That's wrong. That's right.
It bends down always.
Okay, you have to.
Yeah, they say it always does.
You're scared, right? Okay, come on.
No,
that's what they say. You just.
Yeah, of course, you cannot stand it with Witsit once that someone explains something. Only hear yourself. Go ahead.
Well, no, you're just misrepresenting your own side. It's all good. I made one simple interjection. It took 3 seconds.
You're
It's just that you
always
don't want to
doing
be
simple
intellectually honest
interjections,
in the
and
way
then
you are.
Taylor is doing a simple interjection, and then you are whining around that you're.
I can't control what other people do.
Hey, Snoo, sorry, can I
That
just
wasn't correct.
jump in for 2 seconds to say I'm going to drop down to listener because I've been here since 9. Well, for me, 9:30 in the morning. It's nearly 5:30 in the afternoon now. I haven't eaten the entire time, barely drank anything. So
Go take care of yourself, brother.
I'm just going to drop down to listener and go get something to eat. So thanks for having me anyway, guys. I hope people start to like really look at what I've introduced, and I hope people start to use the
I
argument.
appreciate all the effort.
I have a question before you leave. Do you have any like you've been like very respectful this whole time, and I thought that. Do you have any sources or like links or something we can look at?
Like to my work?
Yeah.
Yeah. Well, I've literally just started posting on YouTube more now, so I'm going to start doing a lot of posts on YouTube. I'll drop my YouTube link in the chat, and then I also have another channel, and that other channel is going to be just purely observations edited to music, nothing to do with anything, just pure observation and music, just so people can see the observations that have been done as well.
Well, that was great today. Yeah, thank you so much for everything you brought, and it stimulated a lot of thought and great discussions. And then yeah, I'll cut out the presentation, into its own video, and then this was a long after show, so I can well, I can include some of the after show too. I guess I could include it all, but at that point it's going to be 6 or more hours because it's been quite some time. But yeah, I can cut it out to make it its own video. That way, other people can watch the presentation from the beginning. But yeah, I just want to say thank you, and that was awesome. So yeah, cheers.
Yeah, no worries. Man. Thanks for having me. Sorry we were here for so long to everyone. Some people probably bored as shit, but
they wouldn't be here if they weren't interested. I think everybody's interested in this kind of stuff. It's fascinating.
Yeah, it was great.
I do have more that I can present. I've actually designed and basically worked out how this can work over a flat plane and how the observation would work, why things disappear at greater distances. I actually do have stuff where I've done that as well, but we were too busy talking about everything else. But I can present that another time or whatever. And then I can also, I'd like to do maybe some presentations on how people get mixed up between infrared mirages and globes, because we have a lot of misconceptions on infrared mirages.
Since you've already kind of gone down the path and you've kind of reached to the top of the mountain at this point, I think the only thing you could do is to kind of back up with evidence. Like you have a hypothesis now, which is great. This is a very clear hypothesis. See if you can figure out ways to experiment and test it by different types of observations. I would say the differential measurement would be one way. I don't know how you could set it up. There's many ways. We could talk about it some other time, but just kind of back in your mind, maybe figure out ways you can test for it.
Yeah, well, like I said, I'm going to go do the same observation with the boat when there is no miraging. So that's one thing I'm going to do. But what do you mean by differential measurement?
Changing, like for example, I give you a simple example of seeing something in the distance and then changing your elevation, taking a measurement of angle to the object in the distance, maybe stay very close to the horizon, and go up this building. Maybe take it every floor, maybe a 15-floor building. Every 10 feet, you're doing a different measurement, and then you should be able to get an angle based on the known height above the surface, above the water, and then see if the position of this object in the distance is actually representative by the angle of a flat or a round surface. That's just an example. I mean, there's many ways you can test your ideas by what your hypothesis is and your guesses are of what's going on. And the hypothesis has something to do with this convergent perspective, and at the horizon there's a divergent perspective, following exactly what we all see in reality of boats going over something's horizon. If we all agree that happens, the question is what's really causing it, and you can test for that. I don't know. That's one test you could do, but you might think of others. I would think that'd be in the back of your mind to come up with some different tests that could provide evidence for your and support your hypothesis.
I'll go outside now and I'll take a photo of, because I've built 5 meters of that little perspective grid thing. I'll go outside, I'll take a photo of it, and then I'll post that as well so people can see get an idea of what that actually is as well. So that's just another little test that I'll be doing. So if I can mimic what we see over a 30 feet distance over water, then that's just more evidence to say that we're doing the same thing. But yeah, I'm just going to drop down to listen and go grab something to eat, man. Thanks a lot, guys. Thanks.
Take care.
Much love, bro. Okay, so this guy said that he just conveniently made up some perspective that just says it looks like it's a globe and requires light to bend up with no known physical way that can happen, and that the globe just claims that sometimes light bends down. The globe model claims that there's light. The globe model claims that there's light bending down and refraction always, every single day, always.
Light can bend upward sometimes in very, very unique situations. It does happen though.
Yes, but in, let's say 99%, and that's not an accurate amount, it does bend down. That's correct. So you basically always see a little too far with it. And we know that because we can do the actual geometrical measure. And then we know how much.
Oh, well, you said sometimes, but the globe claims pretty much always. And that's because the observations in the real world don't match the globe. And then they cherry pick all kinds of observations and throw a lot of them out because if you actually accounted for them, it would make your radius value way too big. And what the Globers don't seem to get about what he's presenting is that the Globers say they make a claim of exclusivity. They claim that the fact that objects disappear in the distance, bottom up, and that they disappear over the horizon or behind the horizon can only happen if the Earth is a globe and the surface is curving. It's a claim, it's a positive claim of exclusivity, and he is showing that that isn't true, that due to perspective, the observations would be expected on a flat Earth, and he's showing direct empirical observational evidence of the phenomena that he's invoking and showing inferior miraging, etc. So that you can no longer claim,
he's not showing that. He's just claiming that.
You can no longer, he's not just claiming it. You can no longer claim exclusivity. And again, the funniest part of the whole situation is this is how simple it is. When we go out onto the Earth, look at the Earth,
But could you maybe stop with one claim so that we can respond instead of doing multiple?
When it's really clear outside, we can see further. And you guys want us to believe that's when there's the most refraction.
So he did not show that or demonstrate it or anything. He just claimed that perspective makes it look curved. He just claimed that perspective is working, that bottom-up obstruction would appear. But there is
were you here?
no
hold on. Did you just get here? Were you here for the whole presentation or anything? And are you talking about plain reality, or who are you referring to?
I heard multiple hours before I went to sleep, and now I'm up again.
Oh, so you didn't even know? Can you still?
I was not there the whole discussion.
He didn't show anything though. That's not true. You said he didn't show anything. He just claimed it.
I said he claims that it was due to reflection, but there is no physical explanation why why a perspective should work so that you have a looked bottom-up obstruction. It's just this cone of vision.
Don't even know.
It's the cone of vision and so on, which has no physical explanation behind it.
So you don't even know what his position is. So you're just jumping in to claim it's wrong. So
no, I know.
No. And he addressed it specifically, and he said, what we do for all perspective is we use a flat Earth, we use a flat surface, that we can then replicate these observations over known flat surfaces, even local flat surfaces like lakes, right? And to get the same, like very small areas that are known to be flat, and get the same effects. So
but lakes are not flat. That's exactly the point. He just claims them to be flat without being flat. Even lakes are not flat. Even over 3 miles, you have curvature. Even over 1 mile,
like 3 miles. It's nowhere close to a mile. We're talking about little bitty boats on little bitty bodies. No, not over a mile.
Yes, definitely. You will have curvature over 50 meters. It's just very small.
Okay, so the amount of alleged curvature in your globe model is not enough to account for the effects observed on these very small scale observations.
He just showed mirages that has nothing to do with whole buildings disappearing behind the horizon.
So you just deflected once proven wrong. So you don't know what you're talking about when he's discussing the small local observations over flat surfaces, such as using little miniature boats on little lakes that are known to be flat. You cannot claim that they're curving and that's the explanation because they're in your paradigm over that small area. There's not even anywhere close to enough curvature to explain the observations. If you're not familiar with those demonstrations, I encourage you to go look at them. Maybe
I have seen them. And
then why are you talking about miles then?
These surface effects are based on different effects. You have different situations on surfaces. However, the thing is, the explanation of this is how perspective works. Again, there is no physical explanation why light should bend up, which would be a requirement on a flat surface to have bottom-up obstruction. You would have to have always light bending up, except of the very rare situations like the black swan, where you see it not bottom-up obstructed. And there is no explanation at all why that could happen.
Not true. Like, just because you say something, it doesn't make it true. So, no, that's not the only way. He just now
give me the physical explanation that he gave why light should bend up.
Oh, you just repeated again the whole light bend up thing? You just repeated it. No, that's not true. It doesn't become true just because you say it. No matter how many times you interrupt me to say it again. Notice how you complained about being interrupted, and you are incessantly doing it 2 words into my response, back to back to back times. So,
because you're not responding.
How would you know what I'm doing if you interrupted 2 words in? Oh, you wouldn't, would you? The answer is that you wouldn't. So just because you say it can only happen if light bends up, that doesn't make it true, right? He was pointing out perspective, converging the horizon, being the dividing line of perspective. It then diverges on the other side. So once it gets to that vanishing point of the horizon and converges into that point, it's then going to diverge out to do the exact same thing, just on the other side of the dividing line of perspective, thus causing it to go down optically to your perspective. That's not invoking anything to do with light bending.
Just that these paths are not correct because the line from the bottom, like the floor, is not continuing to the top and being upside down on the other side of the vanishing point, it's somehow making a curve at the vanishing point and then goes down. So everything seems to be in his explanation to curve around the vanishing point and then go in the opposite direction. However, that doesn't work with the sky. The sky also goes down and the floor goes down behind the horizon. So it's absolute bullshit, this explanation, that at the vanishing point, it just turns in a different direction. Everything, literally everything, sky, floor, everything goes down behind the horizon.
Everything you said made no sense.
No opposite thing. And still, if the light travels straight, there must be bending of light to see bottom-up obstruction. You cannot explain it differently.
Okay, so notice how you didn't address the direct refutation of your point, right? Which was that you were no, you didn't. You strawmanned it, claiming that he's just claiming light's bending up and needs to show it. That was a straw man. He didn't claim that. Once you were corrected, you just skipped over it. That's very convenient. Secondly, the fact that stuff in the sky also converges doesn't rebut his position at all. It converges to the horizon. The point is that if there's something that is below the horizon, moving off into the distance, appearing to rise, and then reaching that horizon, which is the dividing line of perspective, it's then going to get into that vanishing point, and then it starts to diverge, causing it to lose information from the bottom up due to perspective.
Okay, so if that's the case,
and there's no curvature involved anywhere. It's literally all flats. And you keep saying curvature.
So if that's the case, what's happening when the sun sets?
I'm almost done. When even in your own paradigm, you have to say, yeah, sure, it looks super flat. So stop saying the word curvature, please.
No, we just say it's big.
So as soon as the sun goes over the horizon, within minutes, the sky starts getting darker. And especially in the wintertime when the sun travels a more direct straight line path over the horizon, it could be like pitch black dark in like 30 minutes. What's happening there? This is all just this, if it's all just this atmospheric refraction or whatever, what is happening there where the sun, the moment it goes under the horizon, the sky starts getting darker and darker within minutes?
Jay, can I ask you, is that a non sequitur? Can I ask you that?
It's not a non sequitur, because what we're claiming is that we're claiming the horizon is an obstruction in the same way that a hill is an obstruction to a person that's like, looks like they're being cut off from the bottom up, right? Someone that's walking down a hill, right? And if we imagine them having a flashlight or a lantern or whatever, we can imagine the same effect, right? But if we're just talking here about some kind of atmospheric effects and the horizon is just, not
what we're talking about. You don't even know. This is like, it was just explained that isn't what we were talking about, and then you said it again anyway, and then deflected to the sunset. It's just so weird.
Because the sun is
I know, but did you do that because if you're willing to admit this, did you do that because you were uncomfortable with like the discussion and what was being said? So you had to did you purposely just be like, let me just jump into something else real quick?
Well, no, because they're making claims about the horizon and characteristics about the horizon. And if we're going to make claims about the horizon, we have to explain this behavior that we see when the sun goes behind this horizon, right?
I mean, you did. This is, I think, the 5th time you did it. You did it 3 times in the after show specifically, and then Travis, I'm your Copernicus, had to like literally like multiple times, like he practically yelled at you. Like,
I mean, you guys hate talking about it because it's an obvious.
Because we're not talking about celestial bodies, though. It's a different topic. We could shift to that topic at some point. But Witsit just laid out a whole thing. It was a sort of back and forth with snooze. There was things laid out, and then you just jumped to these celestial bodies. I hear you. It's a different topic. It could be interesting to discuss.
It's not a different topic though, because it's going behind the same horizon that we've been talking about all night. This behavior happens when it becomes obstructed by this horizon. And this whole argument all night is about what is obstructing these objects behind the horizon. And the claim is, no, they're not being obstructed. Okay, they're not being obstructed. But why is it that when the sun goes down the same horizon, it very much behaves like an obstruction?
Okay, so it is objectively a deflection, right? And then
It's not a deflection. It's a debunk.
It's literally not. And you used a straw man, just like the guy before you, right? To try to claim it wasn't a deflection. Atmospheric effects or whatever. It's like he said, light bending up because it has to be. No. Incorrect. So we know us not taking the bait of your deflection to the sunset doesn't mean that it can't be addressed, right? You're like, oh, so when the sun goes off into the distance and eventually can't be seen anymore, it starts to get dark. Sometimes as soon as 30 minutes after. Okay, yeah, the sun got further away. Okay, so back to the point. The actual point is you guys are claiming exclusivity of an object appearing to disappear bottom up behind the horizon. He's saying, no, not true. Perspective causes the object to converge into the horizon. That's the vanishing point. It acts as the dividing line of perspective. Once you get to that line, it then begins to diverge out like a mirror. It does the opposite, does the exact same thing, just the opposite way, because you've now reached that vanishing line. So it serves as a dividing line of perspective. It then begins to diverge out from that dividing line the opposite way. And now it's going to cause information to be lost bottom up. That's strictly due to perspective. And he's pointing out, everything that we do with perspective is done over an assumed flat surface. All of the math that you're invoking, flat surface, that the same effect being shown over very small, locally, provably flat surfaces. This claim of exclusivity is just that. It's just a claim.
Can I ask a question? This vanishing point or tied into the horizon, is that where you can't discern details on the surface, let's say, of the sea? Is that what's meant by the horizon due to a vanishing point?
You begin to not be able to discern information, yes. The really big point
Yeah,
that I'm
but
very
how does how does that create a horizon?
so again, just the response is another avoidance of the actual argument. That's 3 consecutive people doing it 5
It was
consecutive times. Yeah, that's what's going on.
why didn't you instead try to explain it?
I addressed it specifically.
Instead of just
I addressed your
no, you haven't.
deflection specifically.
So how does that work with it? How does it work
does it work?
On a flat surface? If you have an object up on a flat surface and you move it away such a distance that you can actually discern the details on the flat surface, you would still see the object on top. So where is that vanishing point? It can't be.
Horizon.
It can't be a horizon due to the fact that you can't discern the surface details anymore.
What? That's where the sky and ground appear to meet, and information begins to be lost and not resolvable. It serves as a dividing line between perspective, is the argument that was presented that none of you can rebut. But even the funniest part, for sure, is like, it's like the same point I've been making to you guys for like 5 years. You guys just all avoid it. I mean, there's a couple people that like just straight up stick their chest out and say, yeah, but it sounds so absurd. Most of you don't. Just like he showed, when it's clearer outside and it's better conditions, it's clearer. So more visibility. It looks flatter. We see way further. So when it's clearer and there's way more visibility, we see way further. It looks way more flat. And in your paradigm, for your model to be true, those scenarios are when there's actually the most refraction, and that's an illusion. It's more clear. There's better visibility. It looks way more flat. We see farther. That's an illusion. That's when there's the most refraction. That is ridiculous.
So from my understanding then, is that the further away, when you get to such a distance that you start losing information from the flat surface, this somehow affects a vertical or an object sticking up on this flat surface. How does that happen? Why does the less information of the flat surface affect an object on top of the surface?
It's beyond the dividing line of perspective that we just discussed on repeat.
That doesn't answer the question. That's just a claim.
It does. No, it's not just a claim. He showed videos of it happening. Were you here?
Yeah, for quite a while, been listening in and watching.
Were you watching the stuff he was presenting? Because like when Zanick was going back and forth, he showed Zanick a video. He showed Zanick a video and then described the video.
How you lose? It's still not explained.
The combination. I'm not interested in the really gay.
The combination of the losing information from a flat surface, combined with perspective and an object on top of this flat surface.
You just want to hear yourself talk while you're pretending to ask me questions.
I am asking you questions which you are not answering.
No, you're interrupting me.
Oh, then I'm sorry. I couldn't hear you.
You heard me, actually. So just like when he was going back and forth with Zanick, he showed him a video. He then described what happened in the video. And Zanick said, that can't be true because we know how perspective works with geometry.
No, it's not
the same thing.
Wait, you're misrepresenting what I said. Witsit, can I jump in real quick?
That's like verbatim what you said.
No, but you took, again, this is your classic calling card out of context. That does what it is what we see happen. What causes it is what I was in disagreement with. You know I meant that. You know that's what I was getting at. It just because we see something go over the curve and go down the other side and lose a position in our field of view vertically doesn't mean it's caused by perspective going into a divergent mode. That's what I disagreed with. Clearly, you should know that.
That wasn't the point though. He showed you the video of the ship and then you were like, he described what happened. You're like, that can't happen though because we know what happens.
Yes,
just like right there. Even when you clarified right there, you just called it a curve. You just begged the question. And
yes, in this case, I did.
This is the whole point. When you guys claim there's no other way,
and say it's true,
dude. Like all of you can't help it.
It's reaffirming the consequence.
You can't help it.
It
None
happens.
of you can control
it happens
you all have an inability to just not interrupt.
You ramble on. You drone on for minutes at a time. You just don't let anyone come in there. Look,
I'm nothing true, bro. I was talking about.
You were there. You watched. Let me respond. Hold on. Just be quiet for a second.
Oh my God, bro.
He did describe what describe what caused this phenomenon that we all agree on of something going up to the horizon and going down on the other side. He said it was due to this convergence or this divergence at this horizon point. I said that can't happen based on perspective and natural known laws of mathematics. These is not valid. And you can't, if you want to
natural known laws of mathematics.
Yeah, start showing some balls and start providing some evidence to support your hypothesis, which he did not do. I do appreciate it. He can't just describe what he thinks happening and say that's what's happening.
You can do that. You can do that.
No, I can back it up. Through differential measurements, for example, and through laws of perspective, which are indisputable. No, laws of perspective are indisputable. You know what the laws of perspective are? They're trigonometry. Witsit. Did you not pass trigonometry?
You see what you're doing? Like, this is all you guys can do.
Oh, God. You actually can't. Laws of trigonometry are broken because some guy in his backyard with a couple cameras decided he wants to view the cause and effect relationship completely different. And you're still doing it. You're still talking over people.
Because
that's your excuse.
No, because when you start talking, either the other person just never talks and lets you completely run all over them, or they then have to start to do it back to even talk.
Nice excuse, Witsit. I want you to
It's all
stop listening.
recorded. It's all
Yeah, it is
recorded.
recorded.
Yes,
You're
but
right.
why most people don't even engage with you.
Shut up.
It's like, dude, Zanick, it's factually what you just did, dude. So like,
No, you
again,
started misrepresenting what I said, and then you said, "Yeah, I
yeah,
Don't cry.
I'm not crying." I came back and responded back to you saying, "No, I didn't say that because I didn't." He gave the made up that he had. I call it a made up
so now
cause.
you're rambling again.
Let me finish the sentence. You keep on doing this. I start talking for a sentence, and you start interrupting. He said that this is the cause for the phenomenon we both agreed to, and we both agreed to it. And he made it up. He provided no evidence to support it. Evidence is not a description. You know that, but you've called people out on that forever since I've known you. He did just that. He gave you a description as evidence. That's not how it works, Witsit. You just can't make up something that seems to equal.
Zanick,
Oh my God! You got the point.
I didn't just
All baloney.
provide a description.
It doesn't work.
Can you hear me, Zanick? I didn't just provide a description, Zanick. I showed an actual video showing you exactly what happens. I didn't just say what happens. I showed you exactly what happens. It wasn't just a description. I got a boat, showed you what happens to a boat from both sides of the horizon that did exactly what I said it was going to do.
Then you weren't listening to me.
And I described this a year ago, and then I told everyone this is basically what's going on a year ago. I didn't have the same evidence, even I knew that was happening, so I've got to gather that evidence now. So for you to say that I didn't show any evidence, that's a little bit disingenuous, bro.
Okay.
It's a lot disingenuous,
Paul,
not even a little. It's
exactly.
just it's snaky at this point.
Paul and Gio and company, I totally appreciate your videos. You gave great videos and show, and we all agree that that's what we see in reality. Your description of why that happens, what I disagree with, and I think I was very clear about that.
That isn't the point,
not
though.
the video. That just because we see what we saw, and I would see the exact same thing if I did that test, I'd show the exact same result as you did, just like you did. The difference between you and me in this particular regard is that you think it's due to something other than what I think it's due to. It's that simple. We have a disagreement.
Okay, that was what I said.
To produce some evidence, and evidence isn't a video of what you see. Evidence would be do a test, an experiment that shows that what your convergence divergence relationship exists. I don't know how you could do that, but you're a smart guy. You'll figure it out. And I didn't mean. I'm sorry, I didn't mean to be disrespectful. Witsit brings out the worst.
That's
in
right.
Let
me just put it in another way. Right.
We get contentious. We start talking, and I'm sorry I insulted you during my defense.
All four of you little globers started spiraling because you can't handle me laying out the dismantlement of your belief system.
Can I just throw one extra little point in there? So what I also did with my boat observation was we had a horizon that was at 3 miles away, right? Maybe even slightly less than 3 miles. We're at over an 8-mile distance. So at the height that we were at, technically our horizon should have been 5.48 miles away. Now we had an inferior mirage, and I deliberately did that so that we would create a horizon that was earlier, right? So
I appreciate that.
So what I've just demonstrated to you wasn't just that it's something that I'm saying happens. There's virtually no curvature over that distance, even on your globe, right? So we had a horizon at 3 miles away. I showed you that a boat would go up perspectively by the 3 mile mark and then come back down. And as it was going back down, we see it from my side going down, and he saw it from his side coming up and going down. So
totally agree with you, Paul. There's no disagreement.
There's some pretty solid evidence for what I'm saying is going on. And we both agree.
Zanick, stop interrupting him. Shut up.
Yes. And so just one last point. We both agreed on the optics of what happens, which is as a boat moves away from the horizon, we see it appear to drop below the horizon. And as a boat moves towards the horizon, we see it appear to rise up onto the horizon. Now, I've worded it specifically that way because that way then it has nothing to do with whether it's beyond the horizon or in front of the horizon, because it describes the same effect from both sides. Okay, I yield the floor.
No, like I said, there's no disagreement on what you described and what you videotaped. My disagreement is that this is due to Earth curve. You're saying it's due to some new variation of the law of perspective, which says that things converge up to the horizon and then diverge when it passes the horizon. I'm vehemently in opposition to. Sorry.
Did you miss the part where he said that even within your paradigm, we don't need to hear you repeat the same thing over and over and over, dude.
I'm not repeating. I'm adding. Hold on. I'm not.
What we need to do is go get my measurements with different variables.
Let me just have my sentence. So
that's not true. I've been quiet in here for hours.
Right now, you're still talking. Just put a zip on it. Come on. So he also mentioned he did an idea where there was actually a refractive or a mirage layer, which I thought was great too, because I've done that before and I've seen my observations through a mirage layer, as Travis has done to great lengths to show as well. That showed that the horizon was actually a little closer. But the reason that it goes down after the horizon is not due to the divergent in my mind, and with our mathematics that we all understand, because you can actually see the tops of these ships and things going down, and that goes against the laws of perspective. So what he's telling us is that the laws of perspective can be thrown out because he's found an exception. And I, again, vehemently deny that that's possible. That's it. Everything else I agree with.
I haven't said that they can be thrown out. What I've done is introduce that there are particular things about perspective that we did not understand. They were not described before, and I would say that they weren't described before because what we were doing was just assuming that we were on a ball. So therefore, then when we saw this thing go down and beyond the horizon, we're not even thinking about the fact that it's doing the same thing that's happening in front of the horizon. We're just going, why is it disappearing? Oh, it must be a curved surface, like most people do.
Would you?
Not like something else going on.
So what he's saying is that the perspective is happening on the other side of it, and you just skipped right over the whole. According to your own model, there's barely any curvature at all from that height and over that short of a distance. You just skipped right over that part conveniently.
appeal to proportions. Come on, there are
Appeal to proportions. That's the dumbest thing I've ever heard, bro.
Not dumb, it's actually very smart. Hey, so the point is,
No, it's
is that
not.
there is a little bit of curvature, very small, but that's also, I mean, what defines small? Small is relative, right? So because the Earth is so large, compared to us as people being 6 foot tall, the Earth is very large.
But is it big enough to
Horizon can be around 3 miles, and it can hide ships and boats over 25, 30 miles for sure. We know this because we measure it. Now he's saying it's due to this divergent area of perspective that happens after the horizon that has not been understood by most, not been proclaimed to be known by anybody but him, maybe someone that he's worked with. I disagree, and I would love to see him provide evidence for it. Not what he's done is not evidence. Do a test. Do a set of experiments that if this is true, then we should see that and do that and make sure that they're independent from if this curved surface could also show that same phenomena. Then Witsit, you can't help yourself, can you?
Because you just are in repeat.
I'm giving him some sound advice. Just let me finish it.
2 hours, dude.
I have not said
Now, the one time I choose to say something about it,
just
you want to jump back in and say it all again.
So if you want to do some experiments, which are not going to be able to be possible if the surface is round, only if it's flat, that would be great. I could think of some, but maybe you could think of some too. And then do those tests. Have that test ready to go, complete the experiment, and show that it is independent of the curve of the Earth, and it stands on its own by its own merit, and it can be shown with substantial evidence. That's all I'm saying.
Okay, and how about if I show it in my little test that's going to be 30 feet? How about if I show the same effects in that, and we see something disappear within 30 feet?
Well, you have
I'll be able
to
to have items at certain heights and distances, and I'll be able to see how much actually disappears at certain distance.
Okay, do that.
So if I get the same effects happening over a 30-foot surface, that's just more evidence, right?
Well, yeah, it definitely scaled tests are definitely evidence. Some things scale well, some things do not scale at all.
He's already preemptively looking for excuses, dude. Like,
I'm not.
This is the thing.
I'm being logical. I come from an engineering background, and when I talk about things like this, I'll take it from an engineering perspective, which is not a bad thing. So if I'm going to do a test, an experiment, I'm going to make sure that it can stand on its own. The evidence can. It's not going to be the same for the same kind of test I do for a curved surface. That wouldn't make any sense. You have to something that differentiates it. It might be difficult to do, especially over a short distance, because, well, the refraction thing we've done that drops.
Okay, can I say something?
No, dude, might as well.
Supposedly I'm about to get to say something like the last 7 times. But what actually happens is you don't ever let the other person say something. That's what happens.
That's rich, which is coming from you.
Okay,
Sure.
You're all avoiding the actual point, which is that you guys are making the claim of exclusivity that it can only occur. It can only appear to disappear bottom up behind the horizon if it's due to physical obstruction due to Earth curvature. And explain how it could happen on a flat Earth. This isn't possible on a flat Earth. That's a claim that isn't true. It's now been rebutted. The alternative has now been presented. For you then to say, well, yeah, but it could be either one. Okay, cool. That's our points. Okay, so you can no longer claim that can only happen on a globe. You can no longer invoke it as strictly, exclusively globe evidence. And when you go on to now say, conveniently, you understand the concept of supporting the positive claim, when for the last 7 years you were perfectly content running around just throwing that claim out as if definitively unquestionable. Now you want to present a test that shows that it can only happen one way or the other and provide evidence of exclusivity for curved or flat. Well, that's convenient now, which is cool. Obviously, I'm always in support of that. Just funny that you're now saying that. So engage with that point. Engage with the point that you can no longer claim that it's like, and you never could, by the way. You can't claim that it can only occur due to your reified position that you haven't proven when another alternative is being shown and demonstrated, certainly when it's being shown to occur on smaller scales of known flat surfaces.
I have not seen any evidence to support such a claim. Number 2, we can do things to actually provide that evidence that supports the round Earth. And that's, like I said, through differential measurements, you can actually verify that these objects that are due to perspective, that are going away from you, regardless of the surface qualities, there's no point, any vanishing point, any point of convergence, whatever you want to make up as your new scientific or physics term, will create some scenario, some conditions where an object will not rise to eye level if it starts out below eye level, or comes down to eye level and no farther if it starts out above eye level. That right there is my claim. If you can find an exception to that, some logical exception, right now the exception is divergence after the horizon, as Paul said. If that's true, there should be an easy way, maybe not so easy, but there should be a way to be able to provide some evidence to support that claim. I don't think he'll have the ability to do so. That's my challenge. I would welcome it, but I don't think he can do it.
Okay, so if you look in the text chat, live stream text 1, I just posted the first 5 meters of the structure that I'm building. So you can sort of see what I'm actually doing. If you look straight through it, it's like having a perspective grid. That's only 5 meters of it. I'm building another 5 meters. I'll join that to it. And then I'm putting perspex sides all the way around it. Perspex bottom, like perspex acrylic, clear acrylic. And then I'll basically just put things at different positions all the way along it, little boats, little cliffs, whatever. Put maybe a picture at the end of it, and then fill it with water. Sometimes put cold water in there. Then maybe I'll put some ice in there. I'll put some hot water in there. It's going to be probably getting up to like 30, 40 degrees Celsius over the next couple of months, so the water's going to get nice and warm. I'm going to do that, and then I'll have little temperature gauges all over it.
You are out of control. God bless you, man. You are a man after my own heart. I love these projects. Okay, I don't know what you're going to get out of that at such a short distance, but maybe we'll find some kind of conditions or experiment that actually provides.
You're just going to do it to scale, bro. What do you mean?
Well, some things don't scale like you think they
Oh,
do.
conveniently now the
Well,
perspective
that's just true.
won't scale.
In physics, in physics, that is kind of a known.
That's funny because
known
just I
idea.
remember 30 minutes ago you were claiming that perspective does scale.
Perspective absolutely does scale.
What are we testing? What are we going to be testing?
That's up to Paul. But things like aerodynamics scale very well. Things like strength of
perspective and
materials.
conditions.
Hold on. Strength of materials things doesn't scale well at all. There's certain things that does scale, some things that don't. On this particular test, we oh God, there's so many things that go through my head about what you need to do here.
Yeah, well, just take your time to come up with excuses while I go.
No, don't be a jerk. I'm saying this is great that he's doing this, and I don't know what he's going to test for. I'm really curious to see what the results of the myriad of tests he's going to come up with and what they actually show.
Okay, so just as an example, let's say that I get a little boat and I get it from one end and I make it go to the other end, and it does exactly what I just showed in my video, going from one jetty or one pier to the other pier. Would that back up some extra evidence?
Yes.
And you're going to now publicly admit the Earth is flat.
No, because some of the things, because what's going to happen is anything at eye level that travels down a straight path will be still at eye level. It's not going to go anywhere. So if you have, and water will have some curvature too, because it's following the curve of the Earth. So my fellow
oh my
religious
I
will say,
handle
I'm
this
being
guy,
funny.
bro.
Did you say water curves?
Yeah, water curves.
Over the 10 meters.
Ever so slightly, but
Over 10 meters.
Over the ever so slightly, this is not going to curve. I was trying to make
this guy just invoked the
Earth. It's a joke. Yeah.
Meters, bro. I'm so
you don't get the joke, you find no big deal. Okay.
No, it's a joke now that I said out loud.
Well, that's why it makes it a joke, because you say it out loud. So when he does this test, I'm telling you, anything that is straight and has markers on this thing, because it's a structure that he's built out of some type of metal, it should be at eye level, entire distance. As long as you make sure you set your camera so that it is eye level, its entire path will stay at eye level. It will not go anywhere.
Well, what I'm going to do is just set up 2 cameras on both ends, and I'm just going to let them run for, as long as I'm just sitting at home. I'll just let them run, and we'll see what happens. I might have to enclose the area so it traps a little bit of moisture in there to keep some heat or moisture going in there. Like I said, I'll put little thermometers all over the place, do all kinds of things, and see what we can make happen.
What do you plan to see? I mean, you're going to move a boat from one end to the other. Why are you going to have the cameras running all day long? What are you trying to capture?
Well, I want to see if we get, maybe we get an infrared mirage. So I want to see how the infrared mirage builds and how it disappears if it does. See if it mimics what we see out in the real world. See if it does what happens out there over long distance.
So you're saying every time there's a horizon, there is an infrared mirage associated with it?
No.
Okay, good.
No way. I would never say that. That's a silly thing to say.
Just making sure. Yeah, I don't have good luck with it. So that's a big project, and hopefully you get some interesting
And do
results.
you actually believe that whenever it's really clear outside and we can see further and we can see better and there's better visibility and everything looks flatter and we see further, that's when the most refraction's happening?
No, it can happen on either type of day. It doesn't have to be when there's a clear day.
No, but you have to claim, like when we're seeing further, you have to claim that's when there's the most refraction. And so then when we go out,
when we see farther, that's the proper word. When you see farther, it's due to farther than we should based on the presupposed globe predictions. It's due to
supposition.
So one of the things you can do, I have the luxury of being in a place where I can go to 7,000 to 10,000 foot lakes and things, and we can do it. And that we have 20 to 30% less atmosphere, and temperatures where the temperatures of the air match the water. So there's very little, if any, refraction that you can actually measure. And I've done things like Ty posted the pictures, and you can see the hotels of Caesars and Harrah's that are basically missing the bottom floors. All you see is these trees. And the interesting about the trees is you can see the openings of the trees because they're big, huge pine trees. And if you get close, you can see, these are the trees I took a picture of 17 miles away. And where's the bottoms? So there's no miraging because it's too high. There's little air. You don't have these kind of, although you can have it sometimes at Lake Tahoe, but not often. It's compelling evidence that the Earth is round. It's the same kind of pictures he took, but go to a super high elevation lake and you'll have a whole different perspective of.
Wait, so you're convinced by photographs?
By tests in my photographs, where I'm looking at things.
A photograph is a test?
An observation is a test.
And observation is a test, so everyone is testing everything all the time?
Yeah, no, when I make a change of the independent variable, which is the height above the surface, which is a change of the independent variable, it's a test, experiment. Then I get another measurement, and I take the measurement. It is an experiment. Once you change an independent variable of an observation and have it based on what you think a cause and effect relationship will be, that's an experiment. So
an observation isn't an experiment.
Observation is an experiment. It's called observational sciences are sciences, and this is one of them. You can do a observational science where it shows that you can actually do an experiment for this type of goal of finding out what the surface looks like by measuring and observing objects in the distance where they are in your field of view. Then raise your observation point, which is the independent variable. Do the measurement again, measure that angle, and see if it comports with a flat or round surface. Yeah, that is you're wrong. But thank you for trying.
Okay, so again, what's super funny is like when it's clearer outside and it's more visible, and then you see it look more flat and you see farther. You believe that's. Stop saying that.
Why not? It's true.
It's irrelevant. I said when it happens. No, it's not. So when that happens, you have to believe that it's the most refraction. It's so goofy, bro. Like you can tell when there's more refraction.
How?
You can literally tell because
How?
things are more wavy, things are displaced optically. It depends on what type of refraction's occurring.
Absolutely
But
not
just
true.
like okay, you can say that, but it's just obvious intuitively, bro. When there is more visibility and clearer conditions, and you see further, you're more accurately seeing what's really there. You can see what's further away. And if the water's really calm and it's much more clear outside and there's much more visibility, you see much further. That's exactly what you would expect. That's exactly what you would expect if the Earth were flat, right?
Wrong. On the clearest days, where there is the most clear, most blue sky, and no movement on a day that matches the temperature. For example, at down there in Santa Barbara, like where the oil rigs were token, or at Lake Tahoe, where you get these eerie. I've been down there. I was just out there just a few weeks ago at a friend of mine's mansion. We were running jet skis out there. It was the most bizarre things. So look at this lake. This 20-mile long lake. Maybe it's 30 miles long. Yeah, about 30.
There's going to be another red
All the way
herring.
across it, there's no refraction. It's clear as day. And if you look across, you can see entire shorelines and buildings completely missing. Half of the hotels down at Harrah's and Calneva are not Calneva, but Harrah's and what's the other one? Whatever. They're half missing over 30 miles. And
So
you can
red
see clear as
herring.
day. There's no refraction because that is a day that we expect to see that kind of where there isn't.
Just a second ago, you told me that you can't tell when there's no refraction, but visibly. But that was again predictably a red herring. I'll just ask the question again.
No, because I was at altitude, little air, little atmosphere, very calm day. Know that there will be zero refraction or very little refraction. When we have a calm day at the sea level,
Oh, you see how you
and the
did?
ocean,
You
hold on,
interrupted
if
me.
we have
Now
the
it's your turn
ocean,
to talk again.
if we have, come on. So if we have a
Look
day
what
like
he
that,
does,
the
and then he
ocean,
says,
we always,
"Hold on,"
we
and
have
acts like
we
I'm
have a clear
interrupting
day.
him.
We have more refraction if there's a disparity in the water temperature versus air temperature. You don't get it, Witsit. You keep on saying one way, and it's just not that way.
You see what he does, right? Like he makes his point. I go to respond. He interrupts. And then I start trying to finish what I was saying. And he's like, hold on. Why do you always have to interrupt? Are you kidding? You're just like repeatedly gaslighting the room. Like we didn't all just hear that you're the one that interrupted me. It's so goofy.
Cry me a river. Come on.
No, just it's been like 7 years now. Like figure it out. Okay.
You keep on
My
saying
question was, okay. My question is very simple.
Okay.
My question is really simple, right? It's if the conditions are the most cooperative, if it's the atmos is less turbulent, if it's much clearer outside, if it's much calmer, the water's much calmer, and everything is very flat, and we see much further, that is what would be expected on a flat Earth, right?
Wrong.
Okay, I can't. This is insanity.
Because there are days where there's not that much refraction on those calm days. There's just as many as you'll find that there are these anomalies where these are strange days where you have a very warm air on very cold water.
To say something?
Santa Barbara, just a sec, Taylor. We see this in Santa Barbara. The very warm, strange, hot heat wave days.
Yeah, I second Taylor speaking instead of Zanick.
Well, she's I've
been trying to wait.
Go ahead, time in.
Okay, so actually, ironically, windy conditions would give less refraction because the gradients are more mixed, and that would lower the temperature gradients predominance. Just saying. That's just some peer review papers I read.
Yeah, I haven't seen that to be true in most of my observations.
So if it's mixed windiness, it helps lower refraction.
Well, then what happens? What happens if there's less refraction? Why are those oil rigs half gone on the wind chop water?
Why don't you engage with the point of why she said there would be less refraction instead of just saying, no, my anecdotal red herring says no way.
Not a red herring.
So there's less refraction in windy days.
Why did she say that?
Yeah, she said that. Well, that's perfect because I live in a rather windy place, and down by the sea, there's an island about 37 kilometers from me. From sea level, I can't see the houses down by the sea. If I move another kilometer, about 1,500 meters further away, but up to about 74 meters, I can see the houses.
I mean,
so the refraction then during windy days, which we very often have, should be rather low, shouldn't it?
This is very simple. Like, why did she say the refraction would be lower on windy days?
Because wind, yes,
right. Okay, do you guys agree? Do you guys agree with the premise? Yes or no?
Yeah, I can see that.
Okay, Zanick.
Absolutely.
Zanick.
Yes. Windy days, less refraction.
Okay, so what he's saying is he lives near somewhere where it's windy often, and he sees obstruction often. Right. So you're not saying that because it's windy and that actually will lessen refraction, that's now the only and or even primary condition or variable in terms of if there will be refraction. Obviously, the reason she made that point is because we were describing ideal conditions and talking about the globe's claim of refraction when we see further.
It's a
so it would be a better situation than if it's windy than when it's a calm day, as refraction is less on windy days. Isn't that basically what we can conclude? Yes,
that's what she's saying. Yes. I mean, it does make some sense. Yeah, I think it would depend.
To me, it does so to me too. Which means my observations, which have been done for more than 30 years, because I drive up over this hill, going back home year after year, and I can see the houses on that top, and I can't see down by the sea. and since it's very often very windy, since I live on the West Coast, it's windy more or less all the time. That should mean that the refraction is quite low, and it should be rather stable if the temperature is rather stable.
Well, it depends on like
Measure the temperature gradient still.
depends on like if there's haze there. You can have low
you-
visibility for many reasons.
Can you look at the
You're still not going to be saying that just because it's windy there'll be no refraction.
Can you? No, you're not
No,
saying
I'm not saying that. I'm not saying that. And what I suppose we agree upon is on windy days there is normally less diffraction than on calm
It
days.
makes
Let's take
sense.
pictures. That's fine. Thanks.
I think it does make
Taylor,
some sense.
can you look at
Yes.
the picture I just posted in the chat?
Yeah, I'm
So
looking at it.
which one do you think has the most refraction?
I think they both have refraction.
Which one has more? You said in windy days, which is obviously the second
What do
picture.
you mean more? Like, I wouldn't know unless you measure the gradient. According to the Journal of Surveying and Engineering.
Are some of the now
Can you
this is
stop
not
interrupting me, please?
you said
No,
which one is more? I was going to explain, but if you want to stop talking, go ahead.
I read peer-reviewed papers on stuff like this. That's what I'm going to go off of, not just like some speculation. So according to the Journal of Surveying and Engineering, it says you need to get the vertical temperature gradient to know which way the light is bending. And I cannot sit here and speculate on this picture on which one has more refraction. I would say both of them have refraction. I don't know which one has more or less.
One rig's half missing. The other one is in full entirety where it should be.
Yeah, and
half
it's floating in midair.
Not floating in midair. It's on the water, but you also see the cranes and things that stored it as well. So what I would say that's a 90-degree day. Hold on, it's a 90-degree day with the water temperature being 66 degrees and the air temperature being about 90. That seems to be right for refraction, especially since it's so calm. You'd have this layer of air near the surface that would be in a temperature inversion. That's why I say the brown photo is refraction and the windy photo a few days later is not. Is that a stretch?
Must be Earth curve, huh? So one refraction, one Earth curve. See how inconsistent that is?
I'm convinced.
Wow, that's not what I said, but you said it. Okay, fine. If that's what you think it's due to. I'm just saying
Don't you
which
think it's
more, which one represents where the oil rig should be more closely, you think?
How would I know?
Well, there's some certain tells, and I gave answers for that earlier. But
well,
You think one refraction, one's Earth curve. That's inconsistent. You'd have to measure the gradient according to journals on surveying.
Well, I have air temperature, and I have barometric pressure, and we know what the hydrostatic.
Thank you.
We know what the hydrostatic characteristics of air near water with those type of values would be generally, and we would say that the one that is sinking there, that would be more representative of actuality because of the fact that it is blowing with less refraction, and the upper picture shows all sorts of telltale characteristics of refraction, being everything being distorted, these miraging effects. But you can think, and then we have another picture where we have a calm day, and it's also hidden. So sometimes we get a calm day, and it's going to be hidden.
Yeah, I just spent like literally 8 hours explaining that, Zanick. And then also when you're looking at one that's flashing and you've got like it's a sort of brown hazier day, as I also explained, that what you have is a temperature inversion above like it must be at about 100 feet above the surface. So it's affecting that thing that's at 100 feet. It's not affecting the ground. It's not affecting the ground layer. It's affecting that layer that's 100 feet above. It's a temperature inversion layer. So it's not even on the ground, because if it was going down to the ground, we could see the entire thing miraging, and we're not. We're only seeing it starting to mirage from about 100 feet up. But anyway, the
angle of
you get that dividing line of perspective, and then once the horizon's closer to you, everything beyond that will then start to drop off. There you go, just explained it.
No, you explained it. You didn't give a reason. That's the difference. Explanation
He
is
did
not
give a reason. He did give a reason.
What's the reason? The divergence of
perspective.
So that's what he's got to go show evidence for. The divergence due to perspective. It's something he has to test for and show evidence for it. Right now, he just has videos that we would all show to each other. And
so we all have the same evidence.
Divergence. He's discovered something new. Nobody at this point is smart enough to have discovered it, but he's discovered it.
No, that's not. Specifically, what he said was people didn't even try to really because they just assumed they were on a globe.
You know what would be interesting to do, Paul, is draw a simulation for a round Earth, and you're a viewer. Do a simulation with a computer to say where these objects will be in your field of view. Someone already did this with Lake Pontchartrain, by the way. And Taylor, you should be interested in that. This is old news, but they did a simulation and found out that the bridge curved just like the observer would see based on Earth curve, not by a little bit.
I cannot even take you seriously anymore.
So someone did a simulation showing the sun going down over a flat plane. Would that be cool?
You better show it changing angular size.
Well, it wouldn't have to.
When we see the sun set, why doesn't the angular size of the sun change?
Notice how he didn't say like, oh yeah, well if I'm invoking a simulation, then of course I'd have to say yes. He just deflected to some other little problem he has with the flatter sunset.
Well, because if you see a flatter sunset and it doesn't change angular size, how can it be a flatter sunset?
Rules for thee, not me, eh?
Yeah. Because actually, I'm going to mirror on my channel something that Iro Landucci did just recently in a presentation that he did. And anyone who knows Iro, he's also a computer modeler. What does he do? Witsit, his job is like in computer graphics, isn't it?
Yep.
Yeah, so he does things to do with computer graphics, making models, all that kind of stuff, and he has perfectly mimicked the sun going down. Just adding some refraction in there, like adding some atmosphere in inverted commas, adding the atmos, and showing that the sun.
Your mic keeps cutting out though, plain reality. Like every now and then it just goes out. But I know what you're saying. Like this guy did model the layers in the atmosphere. Like, and once he input those things, like having the sun move over the Earth, the sunset would look exactly as we would predict, like over a flat plane, just by inserting the atmospheric layers, like taking refraction into account. That's exactly what it would look like. Yeah, I've seen that modeled out.
Are you sure?
Is she sure that she's seen the model? I'm sure she's sure.
No, are you sure that's exactly what it would look like? You're making a prediction. Have you done the experiment to actually demonstrate that that's exactly what it looks like? Yes, I heard what she said. You don't need to inform me. You need to shut up.
What'd she say?
What's your issue?
If you heard what she said, what'd she say? Yeah. Okay. She said she saw someone else do the simulation. So.
But made the bold and inaccurate statement of saying that's exactly how it would look.
That's what the simulation shows.
So not a real world experiment, is it?
Do you?
So simulation
shows.
showing.
Did you just jump in the room? Maybe.
How do we know the parameters of the experiment weren't tinkered with?
Calm down. Maybe you just jumped in the room, but the reason the simulation was invoked was because the glober named Zanick invoked a simulation of a bridge. And so then someone responded with, "Oh, I'm sure you keep that same energy." And then if a sunset was simulated over a flat Earth, you'd accept that. So, maybe you should know the context of the conversation before getting all riled up.
It's okay.
I agree. It's okay that you were wrong, and we'll forgive you. We can move on.
Go on.
We were just all laughing at how super funny it is that to be a glober, you have to believe that when it's clear outside and there's greater visibility and the water's more calm and you can see further, that's when there's the most refraction.
Even with refraction, where the hell is the angular size? What happened to it? It stays the same angular size all the way through sunset. How come?
They all deflect away from it, bro.
No, it's not deflecting away. I don't trust my eyes up close. I just look at things based on the mathematics, and its angular size didn't change. And something that's moving away should be changing its angular size. Definitely.
Well, just one step at a time. Like, we're not even talking about the sun, just in general. You believe this because this was a big hiccup for me, When you look out over the water, say it's really, really calm, the water's really, really still and flat, and it's really clear outside, and you have great visibility, and you can see much farther.
Very good.
To believe the globe, you have to believe that in that scenario, that's when there's the most refraction.
Not necessarily.
Necessarily, actually.
But anyway,
by definition.
The reason why I brought that up, the angular size up, is because, again, I keep telling flat earthers, stop looking out the end of your nose because your eyes are deceiving you. But what won't deceive you is something where you're measuring a particular angular size of some object that is supposed to be local. And as it moves away from you, it will definitely, if it's a localized, smaller object than the one we're talking about, it's going to definitely change its angular size no matter how much atmospheric refraction you have going on. So as a result, it will change. It'll change by scale. Let's say there's a lot of atmospheric reactions or refraction. You'll still get angular size change as it moves away, but that doesn't happen. How come?
The issue with that is that, like, you deflected again, well,
because the argument was the statement was done. You guys already told me what you saw, what you thought was right, and I'm saying no. Don't look beyond the end of your nose and trust your eyes. Go out there and actually make a measurement and see what happens.
Well, ironically, bro, your deflection is asking us to trust our eyes and then assume that we're looking at the actual light source and its actual location, and then measuring the apparent size.
Right, but the problem is, as it moves away,
get to the sun. You can't get to the sun yet because, like, you didn't even know that on the surface. You have to assume that that's when there was the most refraction. You said not necessarily, but literally necessarily. Like,
where the refraction doesn't do anything. Well, that's my point. That was my point. You even actually, in fact, you confirmed my statement, which is basically you can't confirm that because of all that refraction that you're seeing the actual size of the sun. What you can confirm is as that sun moves further away through that refraction, it should still change its angular size as it moves away, even if it might be the wrong size of what for that particular day on a normal day when there's not a lot of refraction, the angular size of overhead and so forth. There might be a slight difference, but it would still be reducing as it moved away, and it doesn't reduce as it moves away. There's where your problem lies.
So that isn't true. It does reduce based on all the videos when you count the pixels. 2, it isn't just about the atmospheric refraction. We're talking about the assumption of the actual light source and is in an apparent location. And what exactly, for example, medium is it within, or what? I know this is going to trigger you. Drum roll, please. Layers of some type of containment. Are we observing it through? But all of that is a deflection away from what I'm trying to get you to acknowledge, which is
no, I did acknowledge that.
You said not necessarily. No, it is necessarily, right? Like, according to the globe, it's a certain size, and the geometric horizon is a certain distance away from you based on how high above the globe you are. That's a geometric necessity. So if I'm seeing further than that, then that means that it has to be caused by refraction in your paradigm. So that is actually necessarily.
Your statement is wrong about the pixel size because, again, those are just using cell phones and trying to figure out from a few pixels. Why not use a high-resolution camera? Use a high-resolution camera with a telephoto lens and watch the sun as it goes and disappears. No, they're not. They don't change. They don't change. High-definition video from a camera that isn't zoomed in is going to have a small dot that only is going to be a few pixels across and hard to measure.
With solar filters. These are videos by like Woofy 60 or whatever. The guy
what was the name? What kind of camera?
He's like some astrophotographer that's a glober. He posted the video to disprove flat Earth and show that the sun doesn't change angular size using a solar filter.
And it didn't.
And then we took his video and showed that if you actually count the pixels, they change.
What percent change? How much?
It was like 20%.
20% change. I'll be willing to bet that was wrong.
It was super embarrassing.
No, it's not. I'll be willing to bet it's not. And I demonstrate certainly with a telescope and a camera attached to the telescope, same thing happening. The sun moving away and not changing it. A sun going that distance should change its angular size drastically and never disappear across an ocean. It should never go, disappear. It should always be there, but it doesn't for some reason. It lights out,
literally. Angelo, that's one of those pictures that shows like it all blurred, and then it gets near the sunset, and all you see is the sun because it's been filtered through the clouds, where you can see more of a ball. Where above all the glare, they count the glare in its angular size.
No! Stop lying! I just invoked a globe earther, Woofy 60 or whatever, who supposedly was going to debunk flat Earth with a solar filter, showing the sun didn't change angular size. We then took his own video and showed that you can count a difference in pixels. And
so let me ask you this.
This is assuming actual location of the light source. It's just an assumption. It's stupid. And then for you to say, well, I don't think the atmosphere would do it that much. It's just a baseless claim. Furthermore, what if it isn't only the atmosphere that you have to account for when it comes to the apparent location of the sun?
Is that the only video? Is that the only video out there where a glober demonstrated that the angular size of the sun doesn't change? Or are there hundreds of videos out there that show that, and that seems to be the only one you want to find that doesn't?
No, that's a straw man. This is what happens. You guys
not really a straw man. It's a demonstration of fact.
You guys all make claims. No, it's not.
There are multiple videos out there there are multiple videos out there demonstrating that.
Calm down, man. Like, you got to stop making claims about stuff you don't know anything about. So, no, we looked at all the glober videos that claim that, and then we asked for like a year straight for the globers to bring us pick any one that they claim shows the angular size of the sun doesn't change. And every one they brought us, when you count the pixels, it literally decreases in their own claimed evidence. So do you have one that you want to present? Have you actually done that? Have you actually counted the pixels? Oh, we've now shifted to it. I'm glad we all agree that the angular size of the sun is going to change. And now we're discussing how much it's going to change. So we are progressing the conversation.
Not through the day. Not through a day. Through a year, yes. Not through a day.
No, throughout the day. These are time lapse of a day.
Yeah, it doesn't change much.
Now it's not much.
But how much? If it's a few pixels, you mentioned 20%. I've never seen any videos where when they use a proper camera and a filter that the sun has changed by 20% during the day.
Yeah, I mean, so if you guys counted the pixels on any of these videos you were claiming as evidence?
20%? That's a hell of a lot.
Question mark. Have you guys counted any of the pixels of any of these videos that you're claiming as evidence?
Well, if it changed by 20%,
the answer is no.
You don't need to. All you had to do was just make a screenshot from, let's say, just before midday and then after midday and compare them.
Wow, very rigorous.
20%, you could easily see that by your eyes.
Okay, so maybe the globers would like to support their positive claim here, where they claim that if you use a solar filter, the angular size of the sun doesn't change, because what happens is...
And what we're talking about is that particular sun at the bottom is a little oval because that's what happens due to refraction as it gets near the surface. But so it is smaller in height. But if you rotate that sun, the diameter is a lot closer to the other suns that up until that point. All of a sudden, at one moment in time, in that observation near the surface, it does change a little bit. That's getting a little bit disingenuous.
I just want to recap here, right? Like how hilarious it is that the first claim that was made and is always made is that, first of all, it's just a straw man of the flat Earth, right? It's a caricature of our position anyway, but we're not making definitive claims about what the sun is, its actual location compared to its apparent location, what medium it's in, et cetera, et cetera. And then it's not accounting for any atmospheric effects whatsoever, right? And of course, if the sun was getting smaller in apparent size, but then going through the more dense part of the atmo, and if it's getting further away, it's going through more and more and more of the atmosphere, right? Not accounting for any of that. So just an egregious straw man in all accounts. And then the claim is that it doesn't change angular size. And then they just all say it as if they know it's true. And I say, oh, okay. So I'm sure you've done your homework. And
I actually had Geo do my homework for me. He posted a picture.
I'm sure you've done your homework and diligently looked at this video that you're claiming exist and counted the pixels, but not one glober in the room has actually done that. So
you don't even need to use a video. You can just use time-lapse photography and take the last 3 shots, like what happened here in Geo's picture, where all three sun images are overlaid, and there's only a change of 12 pixels. 12 pixels
Okay,
from
so is it changing angular size?
Almost finished. 12 pixels from 302 to 290. Less than 5% change in the size of that sun as it's setting. And the problem is that shouldn't it still be seen?
What percentage does the globe predict it would change? Does the globe predict that there would be a 5% change in angular size?
Sure, especially when you're getting close to the surface and you have a little bit of a reflection, of course.
Not even close.
Absolutely. We don't see anywhere near there, 20% above the 20 degrees above the surface, no, or above your head. It doesn't.
No,
it's
it's
coming and going. Right? It should
0.08
be half
arc
the size.
seconds. It's
It should be half the
0.08
size.
it's 0.08 arc seconds from zenith to horizon, and that's a geometric cause of change in angular size. You guys do know that your model does claim the sun changes angular size.
Ever so slightly. Yeah, as it goes towards the horizon, also you have to understand you are now slightly further away from the sun than you were during noonday.
Right. Okay, because of just spherical geometry.
Yeah. For spherical geometry.
Okay, so in 0.08 arc seconds, that's a really, really small amount, right? I mean,
yes, it is.
You guys are probably about to claim that we can't even actually measure that.
But you got a point. You got less than 5% change in the size of the sun.
Can we go one step at a time? Are we capable of measuring that 0.08 arc seconds?
No, it doesn't matter.
It's 0.08 arc seconds. Do you guys know, or do I know?
Yeah, you're going to see very little change in that. Yes, if you had a clear sky or no atmosphere at all while you were looking at the sun setting, you would see that slight change with instrumentation, but not with your own eyes. No.
So we do have instrumentation that could measure that.
Absolutely.
Okay, so has
the solar observatory has equipment which measures it very accurately.
Right. So can you guys provide evidence that has shown the sun changes angular size, the amount predicted by the geometric claim of the globe, please?
Well, do we then need to take in the atmosphere effect as it gets close to setting? Or could we do that, let's say, when it was 10 degrees above the east horizon and then 10 degrees above the west horizon?
Wait, so
that would be a much better because then you're not that affected by
I think you're right.
Yeah,
I agree with you. Yeah, that makes sense, right? In fact, you should be able to show the gradual change from zenith to the horizon. It should be changing gradually the entire way. So it should change from sunrise to noon and then noon to sunset. It should be gradually changing in angular size, both directions, right? It should get bigger and then it should get smaller. Well, I remember it being 0.08 arc seconds. That might not be correct. This is weird though, because it's your claim.
So 0.012 or 13 degrees.
It's your claim, right? So it's weird that I'm having
hang on. 0.8 arc second is about 0.013 degrees, which is hardly anything. If you add in a tiny bit of atmospheric effect, that does not change.
Whoa,
in angular size at all.
We just figured out how to fix that problem, though. So,
you did?
Wait, let's just take it step by step. You guys are going to be okay. You can get through this. So, just to clarify, you guys are claiming that at the horizon, the atmospheric effects, which in your paradigm would be astronomical refraction, is the greatest, and that astronomical refraction, which is the greatest near the horizon, is going to cause the apparent size of the sun to appear to get slightly bigger. Is that correct?
Is that with or without solar filters?
It's all going to be with solar filters, bro.
Okay. And do the atmosphere have more effects towards the horizon than, let's say, from 10 degrees to 10 degrees above the horizon? Yeah. Okay. So why? But hang on. So then, why should we use the worst? Why should we use the worst possible position of the sun?
I didn't say that you should use
its angular size during the day.
Stefan, is that how you pronounce your name, Stefan?
Yeah, but just about.
Is it, okay.
Good enough. Stefan.
You're not listening. Wait, say it again. Stefan. Okay, I'm gonna butcher that.
Yeah, okay. Perfect.
All right, brother. You're not listening to me. Okay, I agreed with you that in your paradigm, the atmosphere, the refractive effects would be the greatest towards the horizon. And so I don't know why you're asking me why would I want to use the place that the effects are the greatest. I didn't say that. I said you should actually be able to show a change the whole way. In your paradigm, it's changing because of geometry, right? So it's going to change from sunrise all the way up to noon, and then noon all the way down to sunset. It's going to get bigger to noon and then smaller to sunset, right? And so you could pick you should be able to just show the measurements the whole way. And I just am clarifying before we go to that next step, then what we're claiming is that the refraction, which would be astronomical refraction, right? That refraction near the horizon is going to cause the sun to appear to be bigger. Is that right?
By using a solar filter?
Again, yes, we're using a solar filter.
I get the impression flat earthers are cherry picking their statistics. They want to have the sun as close to the atmosphere as possible to make every variation out there be an indication that there's change in angular size. When if you measure the sun across most of the sky before and after, before sunset and after sunrise, you're going to get no change in angular size.
Can I be honest with you guys here? This is more of a meta point, right? But I think that what happens is when I start to guide you through like the thought process of these claims, you guys just assume I'm always setting you up. which to be fair, I usually am. And so you're really like hesitant to just engage in good faith with intellectual honesty. It's very frustrating. Okay.
How do you call it intellectual honesty when you set the goalpost?
I just specified 3 consecutive times that I am not suggesting that we cherry pick observations at the horizon where refraction would be the greatest. Okay. I'm asking a very simple question. If we're claiming that we may not be able to measure that angular size change that is geometrically required in the globe model, once it gets near the horizon because of refraction, that would mean that you are claiming the refraction is causing the sun to appear to look bigger, right?
But the difference between the sun being overhead
Why can no one answer
the sun being overhead and being halfway to sunset is about 5,000 miles, and there's no change in the angular size on a local sun.
Okay, see if anyone can answer the question, bro. Like, are you guys claiming that refraction near the horizon would cause the sun to appear to be bigger?
Sometimes bigger, sometimes slightly smaller, depending on what the density of the water molecules and whatever's causing the refraction. Yeah, sure, it can be changed in either direction.
Oh, can you explain that? Can you
explain
the
lensing effect?
process of these?
It'll move it. Yeah, it won't stay the same size as it goes down. As you measure it, it'll slightly, get larger and smaller and larger and smaller as it goes through layers of the atmosphere with various degrees of refraction. So in that instance, yeah, there's a change. But again, you have literally decided to cherry pick the sunset as the only measurement for angular size, when in reality, a sun overhead versus it's not straw man. I'm just calling out your basically cherry picking fallacy.
It's a straw man. I'm not cherry picking it. This is now going to be the 5th time I've said it. I'm not suggesting that we cherry pick the observation near the horizon. I'm saying that in your paradigm, you would see the sun change angular size the whole time. So there's no reason for us to just cherry pick near the horizon. According to the globe model, the angular size should change from sunrise.
Not our paradigm, your paradigm of a flat Earth. It should get smaller.
You guys should support this point if you were truly confident in the globe model, because this would be a difference in a flat Earth and a globe Earth. On a globe Earth, we're on a sphere, and then we're spinning. And so during sunrise, we're doing this super epic nosedive towards the sun, causing it to appear to rise in the sky. And then it's going to go up to noon and then down to sunset. And so the angular size is going to get bigger from sunrise to noon. And then it's going to get smaller from noon to sunset, because you're going to reach the apex over a ball, right? It's a sphere. So the distance from you to the sun changes from sunrise to noon to sunset based on just spherical geometry. Okay, that's not the same on a flat Earth, right? So then,
what's the difference on a flat Earth?
That should be a difference just on basic geometry. You have plane geometry, spherical geometry. So you guys should be in full support of this, unless there's a part of you that actually isn't very confident in your model, and you always shy away anytime you get towards something that would actually show some definitive difference. And you're afraid to test this because you're not confident the sun will change angular size like the globe predicts. It needs to get bigger and then smaller throughout the course of every single day.
My preacher. Guy, you got to stop sometime, Witsit. Let us answer you. And the question that you posed to us,
repeat myself.
No, you're repeating yourself on your own. Nobody's forcing you. So anyway, I'm addressing it right now. Basically, what you have done, and very artfully have done, is tried to sit and put it into our field that we're the one making the claim of constant change of size of the sun all the time. No, you're making the claim that the sun is local. So we ask the question, is the sun going to then, wouldn't it naturally change size, angular size, as it moved across the sky, especially since it is local? The amount of change across the sky on a sphere with a sun that's 93 million miles away is so imperceptible to the naked eye, you're going to have to use instrumentation to show any change of angular size at all. However, in a flat Earth with a local sun that is supposedly, according to some people, 70 miles wide, should easily show an angular size change just from solar noon to, say, 4 o'clock in the afternoon. That small 4-hour change should be more than enough to show a big change of 20 or 30% in angular size as it moves farther away from you.
According to some people, right? Well, that's a cool story. I've already addressed that the likes of McCune and et cetera, right? You guys love to tear apart a straw man of flat Earth. I cannot account for what anyone who claims to be a flat Earther has said.
I think you that wrong in the definition of straw man, because what I stated was a fact. There are flat Earthers who make that claim.
Well, I'm sure you can say that, because anyone can say they're a flat Earther. I don't care though. I'm not saying that. So that's an entirely irrelevant point, right?
But then you agree there's a change in angular size?
Dude, I'm not actually even claiming to know what the sun is. I'm not claiming that we see the actual location of the sun. I'm not claiming it has a diameter. I'm not claiming it has a distance. Yes, I would claim it's more local than you claim. That's for sure. Hence why it's warmer at noon. But I would love for you guys to stop running away.
What?
I would love for you guys. I would love for you guys to stop running away.
So what about high altitude balloon? The angular size of the sun has been measured several times by using really high altitude balloons, and the angular size changes at different times of the year, just a few micro arc seconds. So that means the measurement is done with hardly any atmospheric effect, and the angular size changes extremely in a small way, even
That makes perfect sense
during
within my
a year.
conception of the sun's just
Yeah,
we see an apparent light
apparent.
source.
What do you mean about
This is
apparent light source?
all a deflection away, though, because you guys clearly do not know the answer to my question, nor can you support your model, which claims the sun changes angular size from sunrise to noon to sunset. You desperately want to tear apart a straw man caricature of flat Earth, but you don't even want to examine your own positive claim. You are claiming the sun is a specific size, and it's 93 million miles away. And it's being observed on a globe that's 3,959-mile radius, and that we are rotating 1,037 miles per hour east of the equator, and that due to that rotation, it makes the sun look like it rises in the sky. You're making hyper-specific dimension claims, right? And so I'm saying, okay, if that's true, then we should be able to test that pretty easily. You should be in full support of my point because it shows a fundamental difference between a globe Earth and a flat Earth. On a globe Earth,
I have demonstrated that. People have demonstrated it.
On a globe Earth, it gets bigger and then smaller. On a flat Earth, it wouldn't do that, right? So
what?
On a flat Earth, it should do a lot more than it does.
Yeah.
Wait. You guys think on a flat Earth it should get bigger and then smaller?
Of course, as it's coming towards you, it's going to get larger as it comes up over your head, and then as it moves away from you on a flat Earth, because it's going to be physically moving miles away from you, not like the 93 million mile difference between with the Earth, and that small percentage of movement is not going to be detectable. Whereas on a flat Earth with the sun local, it's right there in front of you, from sunrise to high noon. It's coming right at you, going straight across the sky, right in front of you. If you're especially if you're at the equator during equinox, you're going to run into a very big problem there on size and angular size.
Try to stay on topic. So then you guys agree that I'm making an amazing point here, which is there's a difference in the cause. So the cause is technically the same, it's distance away, but there's a difference in what causes the change in distance, right? And one is simply geometric and it's very minor, right, in relation to the ultimate distance. So a few thousand miles compared to 93 million miles, right? So then we certainly have equipment capable of measuring this. You would have solar filters and you'd be able to see the sun changing angular size. The problem that you guys have, and the reason you're all desperately trying to avoid it, is it needs to change a very specific amount. It's non-negotiable, okay? So do you guys have any evidence that the sun actually does that in reality? I find it very ironic that you guys really want to harp on a claimed angular size change of a flat Earth, so much so that you'll plug in random arbitrary values and try to pin all of flat Earth with it, but you won't even do the same thing to your own belief where you do have specific values. Does any glober in the room? I've been asking for a year at least. I've been asking for 2 years at this point. Do you guys have any evidence that actually shows that the sun changes the 0.08 arc seconds from sunrise to noon and then noon to sunset, like your model predicts?
Now, why would we go to the bother of showing you a small change like that using whatever instrumentation, and maybe the Solar Observatory does that, just to make you happy with it? And by the way,
aren't you here to help us get over our ignorance?
Yes, I am. Give me a second here. I'm going on with that. I'm concerned about Witsit's back. He keeps patting himself on the back on how he thinks that he's winning this argument about this, when the demonstration is, does the sun change angular size over the entire course of the day? And the answer is not noticeably in any way, shape, or form from any observation, including flat earthers who've taken pictures of the sun well above sunrise, well above, to high noon and all the way to near sunset, and not notice much of it, if any change at all in angular size until sunset, when you have obviously atmospheric distortion going on and you're going to get a variable sun. I've taken photographs or films of planes landing at LAX during sunset, and just the exhaust of the planes changes the size of the sun. Just the actual atmosphere in the way changes the size of the sun off and on, and it swells and shrinks and so forth. Again, lots of reasons why that angular size could be changing, but that minuscule amount that you're going for, it almost seems like you're appealing for us to come up and demonstrate that the sun is 93 million miles away by using that as a way to demonstrate it, when there's other ways to measure the distance of the sun, rather than focusing on the real question is, if an object that close in a flat Earth, because I don't care about the globe, I want to know more about this flat Earth that you guys claim, and you don't even know what the sun is. I find that to be quite ignorant.
This isn't helpful.
Yeah, I mean, that was a bunch of fillings, right? But I don't really care. Apparently you don't understand this conversation. The globe is a model claim. You're claiming to know exactly what the Earth is, very specific size, very specific dimensions. Yes. You're claiming to know everything. Okay, so I am challenging that claim, and I'm asking you to provide supportive evidence of that. This was your topic choice, angular size.
That's the problem.
Well, you
just right. What do you mean by evidence for this?
That you don't actually have evidence, and you all blindly believe it because it's
basically accepting the evidence is basically an appeal to your own authority rather than ours.
No, this is your claim.
So are you saying,
you're admitting that you believe this happens, but you've never seen it happen. You have no observational evidence or measurements of it happening, and you just blindly believe it because it's basically a religion.
Does the angular size of the sun change during a year? It cannot be measured.
Why are you deflecting? Yes. Though? We're talking about
just a question.
daily change.
Yeah. Yeah, that was just a small point.
Okay, you guys could just admit that you don't have it.
But hang on a minute. What's the approximate distance to the sun in the flat Earth model?
I'm not claiming a distance, so that's irrelevant.
But you do agree if it was close. You do agree if it was close, perspective tells us that it should change in angular size during the day quite a bit. Yes.
If we're seeing the actual location, and if it was really, really close and small, and we were seeing the actual location, not making those claims though, I don't believe we do see the actual location.
So Witt's claim is that we don't perceive reality. That's Witt's claim.
No, that's what you claim.
That's your claim.
That's what you claim when I see hundreds of miles away.
Hang on.
That's what you claim when I see hundreds of miles away. That's what you claim when I see the sun is still up in the sky when it was supposed to set 7 minutes ago. That's what you claim with the vast majority of what's observed in reality. So that's what you claim when the sun and moon are both above the horizon during the selenian eclipse. So I would pump the brakes, my guy.
What's it, real quickly? The angular size, let's say, if you're at the North Pole and you're watching the sun during a 24-hour sun, it's pretty much going to stay constant as it goes across the sky. You're at the South Pole. You claim it's a reflection.
Well,
shouldn't the angular size be a lot smaller?
Well, that would debunk the globe. It needs to change angular size, according to you.
Well, no, it isn't changing the size because it won't change. If you're at the North Pole on equinox day, you're going to have the sun the same distance away from you all the way around as it goes around.
That would be the same for either position.
The point that I'm getting at is, as a result of that, if you go to the South Pole, it's not going to be the same. And here's why. It's going to be slightly smaller because it's going through that reflection that you claim of, which means adds more distance off the dome for your viewing observation point. And therefore, why isn't it changing its angular size when you have almost twice the distance than you do during the equinox?
I guarantee you that the sun did. I guarantee you the sun did change angular size when we were there.
How much?
No, back to an amount. So we do all admit that it does.
Guaranteed. You made a statement. Where's your evidence?
Well, we have solar filters.
Did any of you guys measure the angular size of the sun during the TFE?
No, we do have solar filters.
No, so So you did not.
What?
Compare the angular size.
No, but I watched the sun go
when you were at when you were in Antarctica.
Try and keep up.
So why did you say so?
Try and keep up. I didn't. I guarantee. Try and keep up. You're all incessantly interrupting, pretending that you got me.
You can't run from this one. What's it? You basically made the statement. I'll defend it.
You claim that I'm running when you're all interrupting me.
You do that to us.
You're just goofballs, bro. So
you do that to us all the time. So you're getting a little bit of your own medicine. Answer the question: did you make the measurement or not?
Keep it up. Keep it up. Try to control yourself. Okay. I already said I didn't make the measurement. I said I can guarantee you it does change angular size though, and the reason is very simple. The sun went up and down in the sky while we were there. Okay. Thank you. Okay, so even within your own paradigm, it would change angular size. The sun didn't do a perfect circle. It went up and down as it did a circle.
You forgot about our paradigm does not talk about the sun changing angular size. It accuses your paradigm of changing angular size if it were absolutely true. Our paradigm says there's such a little insignificant change in the angular size of the sun over the course of a day, all the way through sunset and so forth, because of the distance it's so far away. It doesn't change its angular size. And that appears to be
I'm sorry, hold on.
Time.
Hold on, did you say a paradigm accuses another paradigm?
Well, what's even funnier is he just said that our paradigm
claims
that he says it said our paradigm claims it changes a small amount.
Go ahead and run from it again.
He finished by saying it claims it doesn't change angular size. So you just defeated your own position within your single statement. But
how did I do that, Witsit? Just tell me.
You started it by claiming that it does slightly change angular size and finished it by saying it doesn't change angular size.
Perceptible to the naked eye, no. But you seem to say that it bounces up and down in front of you in the sky and it looked like it was changing its angular size. You guaranteed it. I want to know how you came to that conclusion.
What was my explanation?
You said when you're in the South Pole, it was changing its angular size because it was bouncing up and down. It was going up and down as it went across the sky.
I didn't say I could see it was changing angular size.
You guaranteed it.
Yes, because it's obvious if it's going up and down.
That would be like me saying
it's obvious, but you have no. Yeah. So it's obvious, but you haven't got a single measurement.
Even within your own paradigm, it would have been changing angular size. You can't go on like that. Even within your own paradigm, it would have been changing angular size, dude.
How much?
Just a little bit.
Just a few micro arc seconds, or maybe a micro arc seconds.
Perceptible to the naked eye.
Yeah.
Why are we saying perceptible to the naked eye?
That's what you're making your claim.
No, I didn't make that claim. You start off by making the point that we can't just do it with the naked eye, and that's so stupid, and we need to use solar filters. And now all of a sudden, we're supposed to pretend we're cavemen, and we need to ask about whether or not.
How do you make measurements of a sun that doesn't exist?
You guys try and keep up. Your model claims in your model there's a claim. Within your religion exists a claim.
And there isn't one in yours?
Angular size due to the shape of Earth. I'm asking you guys very simply, do you have actual evidence of that occurring at the rate required geometrically according to the globe model? And secondly, you are all claiming that it would be affected near the horizon due to refraction. So are you claiming that refraction causes the sun to appear to be bigger at the horizon?
As I mentioned, they have been doing high altitude balloon angle measurements of the sun. to get above most of the atmosphere, to get away from refraction.
That wouldn't get away from refraction.
And the change of angular size is in a few micro arc seconds during the year.
So
and these measurements are done during the day. So not just one measurement, many measurements during the day. And the angular size, what did it say? Hang on, Jesus, where did it go?
Okay, so it's not a micro arc second. I don't know why you're saying that.
Micro arc second.
1 millionth of an arc second?
Yes.
It changes 1 millionth of an arc second.
A few arc seconds.
A few arc seconds or a few millionths of an arc second?
What is an arc? A millionth of an arc second? You mean a trillion?
That's what micro means, bro.
Yes. Did I say million of arc second?
You said micro arc second.
Micro arc seconds, yes.
A micro arc second is 1 millionth of an arc second.
Yeah.
Okay, your model doesn't claim that. You just made that up. So let's go back to the actual. Let's go back to the actual
now you're fucking lying.
Okay, please tell me where your model claims that the sun changes 1 millionth of an arc second.
This is not from the model. This is from actual measurements done by high altitude balloon from I think it was from 19. Yeah, I can find it. 1972 to 1991.
The problem that you don't seem to be thinking about is that even if you go to high altitude, if you wait for the sun to set, as it's setting, you're still going to be observing it through many layers of atmosphere and towards the bottom layers of that atmosphere, right? When it's setting, you're going to be viewing that sun down at an angle through to the bottom layers of the atmosphere at sunsets. So you don't avoid that just by gaining altitude. Duh. I know you don't have any empirical measure. What part of that?
So you think they do this? You have to do these measurements until the sun sets, observed from these high flying balloons. Why is that necessary?
No, that wasn't the point. But if you're claiming that when we go to high altitude and we measure the angular size of the sun and we're measuring to the precision of micro arc seconds, that's your claim, which is a millionth of an arc second, then we should absolutely be showing that it's changing up to 0.08 arc seconds from sunrise to noon to sunset, right?
Witsit, I posted 3 studies that show exactly what that is. And you can look at all 3 different studies that were done, peer-reviewed studies showing the angular size of the sun being measured, slightly changing those few milliseconds, micro arc seconds, and so forth that you're talking about. So it's all right there.
There's no micro arc seconds, dude.
Go ahead and read the articles, and it'll demonstrate what you claim is not being demonstrated.
You haven't even read these.
I don't have to. I already know that what these articles are saying. I read the abstract.
No, you don't know what they're saying. You haven't read them. Okay. So micro arc second is 1 millionth of an arc second. That's such a goofy thing to say. Please stop saying it. Okay. If we can get back to the point.
Would you rather we call it mass?
Well, I'd rather you say terms that are accurate, that would be cool. So you like the micro arc second comment was just really goofy and you just kept saying it. So I had to correct. You clearly didn't seem to know what that meant. That's an actual term.
Oh, for fuck's sake, I do know. I absolutely
You were intentionally invoking a millionth of an arc second.
So now he's going to attack the data.
Yeah.
So what instrument was used to measure the sun? Wait.
It's actually a balloon-borne instrument. It was done on a balloon.
Okay.
It was used a solar disk sextant. In my example, they used what they call
in the 50s on a balloon to measure to the precision of a millionth of an arc second.
The measurements were done between 2002 and 2005. No, not in the 50s. Nice try.
Some guy claimed something about the 50s or 60s earlier.
Not me.
No, I did not.
Yes.
From 1992 to 2011.
Okay, well, you're now saying that. You didn't say that earlier.
Didn't I say 1992?
Just get on with it. Accept the fact that we brought you the data you asked for. And now that we've presented you with that data, tell me what's wrong with it.
Well, okay,
How did they stabilize?
There is no way that this paper is about to claim that they measured the sun on a balloon within the precision of a millionth of an arc second.
Do you see the
milli arc seconds? Move on.
Okay, so yeah, because the bigger point here is like I'm actually trying to expedite. You guys are being pedantic in bad faith. According to the globe, you got sunrise, you go to noon, and then you go back down to sunset. There's a 0.08 arc seconds. If that number's right, I asked you guys if you knew the real number. I guess you don't. I think it's 0.08 arc seconds from sunrise to noon, and then noon to sunset, right? And that's because of just spherical geometry. Okay, now I did ask, do you guys have any actual empirical measurements that happens? Everyone in the room started saying, oh, when you get towards the horizon, you're going to have your atmospheric refraction. Right, that's going to affect it, and you're not going to see the angular size change. So then I asked the logical follow-up, which was, okay, so you're claiming that within your paradigm refraction, and this would be astronomical refraction, near sunset or sunrise, is that refraction is causing the sun to appear to be bigger, right?
No.
Well, that's what they're claiming. If they're claiming that it does change, like say it is getting smaller, the angular size change is getting smaller in the globe, just a very small amount, but if you go to measure it, that it won't be measured as smaller because of refraction, then that would require the refraction be making it appear to get bigger.
The quantity that we're talking about of actual change in angular size, we can't measure, right?
Okay.
Us taking photos, we can't measure that.
And that's what I've heard before. This is so at the beginning of this conversation, I said, I'm sure this is where you guys are about to claim that we can't measure it. And then they all claimed we could measure it. And now they're claiming to drop papers that they did measure it. So, I mean.
Hey, did anyone catch Professor Parks' measurements the other day?
Of what?
Professor Parks, he did a live and he was talking about using one of his, I guess, students' fMRI, and it was measuring the difference in the at certain times. I didn't catch the times, but he did say that there was a noticeable change in the size, the angular size, right? I didn't know if I caught that the other day.
How much
Dude,
did
this
angular
paper,
size change?
dude, this is so funny, dude. I can't believe you posted this paper. You didn't even read the abstract, dude.
Which one are you looking at? There are three of them.
I'm going to read it. This is why you don't just Google.
You're going to cherry pick what you're going to do. Tell me which article you're talking about.
Stop interrupting me. It's not going to save you. Variation of the diameter of the sun has
I don't know which article you're reading from, so I don't even know if you're lying right now.
Bro, I'm reading the title of it. You're just freaking out because you know this is about to be really embarrassing.
There are three of them. Health science.
Right. Well, we'll go one at a time, my guy.
Okay, health science, the first one.
This is how science. Yeah. Okay. Variation of the diameter of the sun is measured by the solar disk sextant. You claimed, because you posted them, I'm like, you haven't read these, and you said, I don't need to read them. I know what they say.
I didn't read that one. I read the other one, which was much more accurate.
You didn't read any of these, and you may have read the abstract of one of them. Best case scenario. But anyway, this is
what would you like to know about the one I just finished reading?
I'm about to just debunk you just a second. The abstract of this says that the balloon-borne solar disk sextant experiment has measured the angular size of the sun on 7 occasions, spanning the years 1992 to 2011. The solar half diameter observed in a 100 nanometer wide passband centered at 615 nanometers is found to vary over that period by up to 200 mass, while the typical estimated uncertainty of each measure is 20 mass. The diameter variation is not in phase with the solar activity cycle. Thus, the measured diameter variation cannot be explained as an observational artifact of surface activity. Other possible instrument-related explanations for the observed variation are considered but found unlikely, leading us to conclude that the variation is real. The SDS is described here in detail as the complete analysis procedure necessary to calibrate the instrument and allow comparison of diameter measures across decades. That has literally nothing to do with the angular size change of the sun daily due to the sphericity of the globe model, and it literally doesn't support your position at all.
I did not say it was during the day. I said it was during the years.
It says they don't even know how to explain it.
No, you don't understand what it says because you haven't read this paper. What they are saying,
they said that it can't be explained. It's not in phase with the solar activity cycle, so it can't be explained.
It's not in phase with the solar activity. What does that mean?
And it cannot be explained by
the activity of the sun.
It cannot be explained as an observational artifact of surface activity. Other possible
activity. What happens during the 11-year cycle of the sun? Does it get larger or smaller?
They're literally admitting that they're trying to figure out the cause and that they even considered instrumental variations.
Did you read the conclusion? Read the conclusion at the end of the article. You went through the abstract. You didn't read the conclusion.
Wait, which part?
We have to conclude that the variation is real.
That's right.
Okay, that's not the point, dude. If they take 7 measurements over the course of over a decade, how long is this? Over almost 2
unlike a local
decades.
sun of one that's far away, it's going to take a lot of time for changes. Sorry, it's not convenient for your lifespan.
They took 7 measurements over the course of 2 decades, and it showed incredibly small variations that have nothing to do with the distance to the Earth. What the hell does this paper have to do with anything we are discussing? The answer is literally nothing. It has literally nothing.
Not talking about the distance to the Earth. It's talking about the angular size observed from the Earth.
The angular size change that we're discussing is based on the distance.
Exactly. And that's why I come back to that very first statement I said when I first came into the room. Why are we focusing on something as so local as the sunset itself and the amount of change that we see, the actual angular size change that has been measured through the solar observatory and so forth being very, very imperceptible to the naked eye? Why are you sitting there and insisting that that's your flat Earth proof that the sun does change its angular size? No, it is not a straw man. It's what you
said. I never said that. Yes, no, that is not what I said. When did I say that?
I'll pat myself on the back now and give myself some bruises.
That's just a lie.
Morning and one at local noon doesn't change size.
Right. So they were claiming that he's just going to say he's going to say that the amount that it does change, you're not going to be able to tell with like a picture, which is a fair enough point. I agree. You're going to have a very specific instrument that can measure extremely precise. To be able to measure.
You agree the sun is far away then, right?
I'm the one. No, I'm the one.
Well, if it's local, why isn't it changing more?
You are the one. You guys are the one that claim that we do have those measurements and we can measure that change of 0.08 arc seconds. I then asked you to provide it. You don't have it. You then all started making excuses for why you wouldn't be able to measure it because of refraction. I then said, okay, so you're saying refraction is causing the sun to appear to be bigger. and then none of you could answer. And of course, that would be an issue for you because then you'd have to apply that same claim to a flat Earth, right? Where if the sun's getting closer to the horizon, that refraction can cause it to get bigger, right? Which of course I wouldn't say that, but like there are magnification effects and stuff like that, right? But you guys just failed on all accounts. You didn't provide the measurements. You didn't intellectually concede or be honest and concede that maybe it's too precise and small to measure, or that you don't know if it's been measured. You just pretended you know it does match the globe exactly.
So why is it, if you're being honest, Witsit, why is it that after all of these claims that you're making, that you sit there and you say, I don't know anything about the sun? Why do you go and hide behind a cloak of ignorance? You said you don't. Well, you say it's local. You deny that. When I told you, you said it's
more local. Yeah.
Okay. How local are we talking about?
I don't make a claim as to the distance of the sun. I don't
Shouldn't you
think
be able to
even see
measure
the
something that
actual
close?
location.
The question, Angelo, should be: is it close enough? Is it close enough such that you would see an angular size change?
That's
Is
what
it in the order of? Yeah, is it in the order of thousands of miles?
I don't think we see the actual location of the sun, right? So like, this is what I was explaining. It may not be the most satisfactory answer for the longing to strawman the flat earth and debunk it or whatever, but that's not really my problem. I don't think we see, I know, but that's what they were doing. That's how this conversation started. There are some flat earthers, right, that claim like the sun is 70 miles in diameter or whatever, 33 miles. And like, I don't know about any of that. I'm not claiming any of that. What I'm saying is I don't think we even see the actual location of the sun. I think there's an abundance of evidence that suggests we don't. And I think that, I think that the earth is contained, bro. I think that there are layers to it. I think we're seeing an apparent light source through that. So I wouldn't be surprised if we don't see immense changes. And what actually started this conversation, though, was that it's like this claim is always made that stupid flat earthers claim that angular size of the sun does change, but they don't use solar filters, or they don't use good enough solar filters. But then when the Glober comes out and says, here's a video with a solar filter showing that the angular size of the sun doesn't change, when we actually count the pixels of the sun, it does get smaller in their own videos, like Woofy 60 or whatever is an example.
No, Witsit. What you're looking at there with Woofy's is a single frame where the sun goes from the top right to the bottom left, right? To do it properly, you need to have the sun in the middle, zoomed in both shots, right? Don't use different parts of the lens to count pixels. Because you know what, Witsit? Lenses have distortion.
They sure do.
Would you like to see how to do it properly, Witsit?
That makes sense to me. At least you're articulating intelligible responses. So are you saying that if you count the pixels when they are both centered, that they're exactly the same?
Well, I did it within 2 pixels, I think it was. Let me have a look at my video.
Okay, because I saw there's another screenshot, there's another picture that Geo dropped in here where it's like, what is it? Like
is your video published, Ruby?
Yeah, I did it on TikTok. Just put the link in the chat just then.
Thank you.
There's one here that's 302, 297, 290, and it's all relatively in the center of the frame. The only time you can even claim some type of distortion is going to be along the edges, right? So, and it would only be pixels along the edge that's affected, that's closer to the edge.